week 3 and 4 week. We'll just go through all the concepts of the week 3 and 4, and then we'll wrap up. So I guess till now we have discussed about the week 1 and 2. So please mute yourself, and everyone please mute yourself. Okay. I'll just make everyone. So whatever the doubt you have, you can just ask me in the chat box. I'll just mute everyone. Yeah, are you able to see my screen? Is it visible to you?
Yes, sir.
Okay. Okay. So I'm just requesting everyone to not like unmute yourself in between, and then so it's better in the end. Maybe after half an hour, after discussing the whole one concept, you can just ask me the doubts. Otherwise, it won't be fruitful or helpful for you also. So let's start with the week 3. So those two concepts I'll be discussing, and then I'll give you an idea which type of problems can come, and then that may help you in the quiz paper also. So until now, we have discussed about the different types of variables, basics about the descriptive, statistic, inferential, statistic, all those stuffs. So from here, we'll just start with discussing about a different type. Like till now, we have discussed about the categorical variable. Now we'll start discussing about the numerical variable and how are we going to deal with the numerical variables. Okay. So in this numerical variable, you can have basically can have a discrete one and the continuous. I guess you're already aware of what do you mean by a variable. Okay, these are basically some of the features that you get whenever you have a data points. The features basically are generally the variable or those type of features whose value generally vary. Okay, let's for example you have a data set. Data set has maybe two variable v1, v2, v3, three variables. So you can have a so this and the values are varying, and this is the case 1, this is case 2, or this is case 3. Okay, so this data set whatever I have given here has basically 3 cases, or you can say 3 observation with 3 features v1, v2, v3, or you can say the 3 variable and 3 case or observation. I guess this is clear. So and in this variable some of the variables can be categoricals, where basically the example are like gender. Okay, is one of the categorical variable, but here we are just discussing about the numerical variable. In the numerical variable you can have a discrete type of variable or the continuous. That's pretty simple, you don't get confused with that. Nobody is going to ask you whether it's a discrete or the continuous. You just remember that discrete is those type of a variable or those type of a variable where the numbers that you're getting is some of a finite number that you're getting. Okay, let's for example you're dealing with some of the variable like the uh, number of house, the number of people is present in some house, or number of maybe some sort of a number of accident on this road, some type of a finite value. If you are dealing with some sort of a finite numbers, okay, or in the continuous, it is one of the variable where the numbers can be in the infinite duration. Infinite numbers can be possible, like you are dealing with some sort of a weight or a height, right, where you already know that in between two numbers also an n number of like for example if you're just dealing with a variable called weight. Okay, so there can be, if you are dealing with food, like for example one people has 44 kg and then 145, so in between this 44 and 45 also you can have an n number of variables that can adjust here, right? So this is a basic difference, but in the exam, it's very unlikely that the people like they'll be asking you whether this is a discrete variable or a continuous variable. But if they're asking also, you just think of as a discrete variable where you can count it. The number that is present here is in the form of numerical variable, but you can count it. Some finite sort of a number is there. And in the continuous, in between two numbers also there can be an infinite number of like that type of variable can be adjustable. Okay, I told you the examples also, some form of a number of accident or something like that. And here it is the variables such as the height or weight or speed of a vehicle, something like that. Okay, is it clear to everyone? Are you able to hear me? Are you like?
Yes, sir.
Okay. So this is pretty simple. Now, whenever we go through the numerical variable that can be discrete or continuous, now how are we going to deal with that? Okay, how are you going to organize those type of a data set? Okay, so first I'll just give you an idea about the discrete. So whenever you are whatever the data set that is available to you, okay, so the features of that, like you were having a data set, and in that set you were having the different type of a case, or you can say the observation that is present, and in that you have a variable. Okay, and that variable is numerical, and it's in the form of a discrete, like where let's for example this variable was the number of people present in some household. Okay, so that was the variable that is basically your discrete, because the numbers that will the number of variables that will be present in each of the cases of the observation will be some sort of finite number. Okay, that won't be finite. I mean the number can be, let's for example that you count it, like can be counted in your on hand also. Let's for example the number can be 1 2 5 7 9, something like that. Okay, so and if you are dealing, if you have to organize those type of a data set, okay, where the number of the variable is very like a finite, then in that type of a data set you can just put it in the form of a simple chart, or you can say you can just put it in this form. Let's for example the example I am just giving you, this was the variable. Okay, this was a variable, and the values present was somewhat like this. So example, so somewhere, so number of people in the household only I'm saying, and then the values can be 1 2 3 4, and then 5 1 7 3 2, somewhat like this. Okay, and if you have getting this, so this is for the first case, first observation, the data from the first observation, this is from the second observation, this is from the third observation. So basically we are having some sort of a 3 plus 3 plus 3, and then let's for example, so we're having 10 observations. You just took some data set where you're just counting the number of people present in some household, and you just took the data set from the 10 household. So you are getting this type of data set. Now you can see that here the numbers that you have got is in the form of some finite value. Okay, and that you can count it, and you have that value, right? 1 3 4. So this is like a very finite number. So you can just put it, if you want to organize this about data set, you just put it somewhat like this. So value what is been given, so this from 1 to whatever the unique number present here. So 1 is unique, and then 2 is unique, and then you have 3, and then you have 4 5, and then I guess 7 is present. Okay, then you can write it the frequency. So number of times this 1 is present, that you can write it here. Okay, so here I guess 1 is present 1 2 times. Okay, similarly 2 is present 1 2 times, 3 is present 1 2 3 times, similarly 4 is present 1 times, and then 5 is present 1 time, and 7 is present 1 time. So this is what you can write it. And then the other thing that you can write is the relative frequency that is present. Okay, so relative frequency is pretty simple, that you have already learned in the categorical variable also. So here you can just write it as the number of frequency that is present for value 1, that is 2, upon the total number that is present. I guess 2 plus 2 plus the 3 plus 1 plus 1. So the total number of count the number of the observation that you have. So 10 basically. Similarly, you can count it for the 2 also, 2 upon 10, and for the other variable also. So I guess for the numerical data set, if a numerical in the discrete form, you can simply behave it like the categorical data itself. Like you can just organize those data sets in the form of a categorical itself. Because in the categorical data set also, where whatever the number of category were present, you just counted the frequency and then divided with the whole number to get the relative frequency, and then you can just put it on the some form of a bar chart. Okay, so here also you'll be doing the same thing. You can just put it in the form of a bar chart. And the exam, which type of questions can come is like they can give you some sort of a frequency, and then they can ask you the relative frequency for some of the data. So they can give you in the form of some chart. Okay, so in this form, if you have asking the like which type of questions can come from this topic itself for the discrete data set, you can be given the information about the values and then the frequency, and then you can be asked about the relative frequency, or maybe the relative frequency can be given for some of the cases, and then you can be asked to calculate the frequency for one of the cases. Okay, so this type of problem can come in this discrete type of a data set. Okay, is this clear to everyone? Can we move to the next part, the continuous one?
Yes, sir.
Okay. So let's move to the continuous data set. So how will you organize this type of data set? Where you have the data set that the variable is in the form of a continuous. So the data set that you are getting in the form of a continuous data. So now you already know that in the continuous data, you can have a variable such as the weight, height, some sort of things like that. So you'll be having, whenever you are dealing with this type of data set, okay, so your data set can be a large number of data set can be there. That depends on the number of observation. Yeah, correct. But there can be numbers somewhat like I'll just give you some of examples. So you can have a data set like, because you already know that the data for this variable can be uh, in the infinite, right? So you can have a variable like, let's for example, the variable that you are dealing with is the weight of the some weight, or maybe the marks of some 50 students that are available in the class. Okay, so that marks can be for this 50 students can be from, let's for example, 45, and then you can have 49, 59, 75, okay, 68, somewhat like this. Okay, and this can go on and on for all 50 students. Okay, so now how will you deal with this type of a data set where the data set is in the form of like you have a n number of data set. Now you'll try to do somewhat like this. Here also you'll prepare some sort of a chart. Okay, and you will try to put it in the form of, so here you will just try to put it in some of an interval. Okay, so you will just create some sort of an interval, class interval. So you'll start creating some class interval, and then in the class interval, some of the red flags are there. Okay, I'll just let you know what are the some of the like some of the things that you should be considering while creating the class interval. Okay, some sort of an interval, and then you will be having a class interval. So you'll create some sort of a class interval. So if let's for example your data, so the values of marks was, let's for example, was from, so the minimum mark somebody would have got was 11. Okay, and the maximum mark somebody would have got by 89. Okay, or maybe 90, whatever. So what you will do is, we'll try to create the interval in such a way, uh, like let's for example, you have just started the creating the interval like 11 to 20, or maybe 10 to 20, or then 20 to 30, 30 to 40, and in the similar fashion from 80 to 90 also. Okay, so the one of the things that should be there in your mind is, whenever you are creating the class interval, you just try to create the class interval of equal length. Okay, so here you can see that the length is 10. Similarly for here also the length is 10. This is advisable. It's not that if you are taking a different, the length of the interval as a different wrong, but it is advisable that you take the interval as equal. Okay, so you can create here for this example also, you can just write it as a class interval as 10 to 20, then 20 to 30, and in the similar fashion from 70 to 80, and then 80 to 90. Okay, and if you are just creating this type of a class interval, you can write the frequency. So you just counted all the numbers that are from 10 to 20. And one more thing is, like whenever you're writing all those values, so 20, whenever you are writing for the first time, you should not be including the 20. So whenever, if you are getting 20 here, so you should not be including here in the number of frequency. So you should be including here. So wherever you're writing for the second time. So if you are writing the class interval as 10 to 20, so 20 should not be included here. And so 20 should be included here from 20 to 30. Okay. And you can write the frequency here. Similarly, you can write the relative frequency here. And the same way, so relative frequency would be the number of value. Let's, for example, the number of values was x. So x upon whatever the total number of data points. So we were dealing with the student, we are dealing with the marks of 50 students. So x upon 50 would be the relative frequency for the class interval 10 to 20. Okay, is this clear to you? So the how are we going to deal with the continuous data set if you have to organize the continuous data set? Is this clear to everyone? Are you able to hear me or not? Okay. 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 So I'll just unmute. You can just unmute. So here some of the terms are there. Yeah, some of the terms are there for the continuous data set. Some of the terms are basically, and yeah, one more thing I was telling about some of the red flags that you should be worrying about whenever you are organizing this type of a chart for a continuous data set. The first thing that should be there in your mind is the interval should be like it's not it is advisable to have a equal length. So whenever we are dealing, so the length of the interval that we are putting up should be some sort of a equal. So here 10 to 20 or 20 to 20, some sort of a equal length should be there. Okay. And one more thing, each observation. So if you are just dealing with this observation 45, you should not be putting in two, like let's for example, this is 40. So you can't put this observation in two class intervals. So you can't put this 40 here also. Let's for example, this is 30 to 40 and then 40 to 50. So this is a red flag that you should not be putting this 40 here and here both. You have to put the observation at unique place, like in the one interval. Okay. And the number of interval that you are creating. So for this case, as we can see that it is from, so you are creating some 8 to 9 intervals. So that is totally fine. So you should not be creating the class interval as more than 20 or 25. Okay. So that is not advisable to create the number of class interval as very like large number. Okay. Yeah. And some of the term, if you are aware of the class marks basically you just take out the average of the upper and the lower limit. Okay. Class width is also, so basically if you are asked about the class width, you just so you just take out the 10 and the to instead of 20 minus 10 would be your basically the class width. Okay. So basically the difference between the lower limit of the class and the lower limit of the next higher class. Okay. Basically 10. So 20 minus 10 would be the class width. I guess this is clear. So class mark is basically the average that you take out. So for any interval, so the average of this two, the 10 plus 20 by 2 upon 2 would be the class mark. So basically the average of the two class limit. And if you have been talking about the class width, so the difference between the lower limit of the class and the lower limit of the next, so the next higher class. Okay. So if I'm asked about the class width for this class interval, so basically for this, it would be 20 minus 10. So lower limit for this class and for the next class. So this is the 20 minus 10. So lower limit for this. So 20 minus 10 would be the class width.
And the range will be the highest limit and the lowest limit, no?
But I couldn't hear you. Maybe you can write it in the chat box because your voice.
सर ये रेंज के बारे में पूछ रहा है.
Okay, so the range would be, sir, like the maximum value, whatever the present here and the minimum. So that would be the range.
Sir, the
Okay,
class
sir.
width is like, sir, the class width is the lower limit minus upper limit, or sir, like I didn't understand that.
Class width you're talking about?
Yes, sir, like the class width of this 10 to 20 interval, sir, it will be 10, right?
Yeah, yeah.
So we don't need to do like the top one and the second downside the one.
So that's the definition. So whenever you're calculating the class width, it's the definition that if your interval is somewhat like this, 10 to 20, and then 20 to 30, then basically the lower limit of the first one, and for the upper, the next class interval, the lower limit for the next class interval. Okay, you take the difference between those two. So
Okay,
basically you just define it like a difference between the lower limit of a class, basically for this class, if I'm calculating class width, and then minus the lower limit of the next higher level.
Basically, the average between the two limits, right?
Okay, so the average is basically the class marks. Okay, this is the class width. So you can say what is the class width? I mean 20 minus 10. That is the basically the class width for each class interval. Okay, and the class mark is basically the
sir, we have
average.
class marks for each intervals, right?
I didn't understand this part.
No, there is nothing. See, what I was saying is if we have organized a data set somewhat like this, 30 to 40, 40 to 50. Okay, and the frequency is 5 and 10. So relative frequency would be 5 upon 15 and 10 upon 15. Okay, relative frequency. If you have been asked to calculate the width, class width, so what should be the class width? So this is basically 40 minus. So for any one, if you are calculating, if the data set that has been given is having equal width or the equal interval, you can just directly write it as a class width is what? 40 minus 30, or you can say the 50 minus 40, basically the 10. And if you have been asked regarding the class mark is what? The average of the two class limit of the class. So basically, for this one, the class mark, if I'm just calculating, should be 30 plus 40 by 2. Okay, and this for this class would be 30 by 2. Okay, is this clear?
Sir,
Yeah.
Class mark is different for each observation, right?
Yeah.
Is class width and height of the class same?
What class width?
And height of the class, are they both same or two different terms?
No, that won't be same, right?
Sir, my doubt is class mark and relative frequency will be different for different cases.
Yeah, that will be different. Yeah.
Class mark is just a midpoint. G.
Yeah, you can say that the midpoint.
Sir, what is difference between class mark and class width and class height?
If you're talking about the class height, so I guess we are talking about the frequency, the number of values that are present between 30 to 40, right? Okay.
That is 10. Oh, the class height? No, sir, that is frequency, no, sir. Values that are present between 30 to
frequency.
30.
You're talking about that only, right?
No, sir, I think class height means the same thing as class width. Like in many formulas I have heard, instead of using class width, they use class height.
Okay, I don't know where it has been written, but I'll have to check. So can you tell me the questions where it has been written as a class height?
No, sir, there's no question about class height.
Yeah. So there can be different terms if you just go through different
Sir,
books.
I did not mean that it is there in some question. I was just saying in it was common synonym for class width and class height. There are many people use both of them together.
So in the
as the
exam,
same thing.
So whatever the term that has been defined here will be asked about those things only. Okay, because see some of the books.
Yes, sir.
Yeah, so because these are very common terms, right? So there can be some indifferent terms that can be used for this class interval and class width and those type of things. Okay. So do not get confused with those, because class height generally will feel like you're just talking about the frequency, but I don't know what is that been defined here. So here it has not been defined, the class height. Okay.
Okay, sir.
Yeah. Okay. So wherever you have been given this type of data set, you can just put it in this form, organize in this form, and then you can plot your histogram. Okay, from here also. Okay, so now the next part is that you will be dealing is stem leaf diagram.
Sorry to interrupt in between, sir. Sir, I have
Yeah.
small doubts here. So suppose in
Okay.
the data set we are asked to, the value is given out 20. We will keep in the interval 20, 10, 20, or we will put it that in the interval 20, 30. Sir.
Which one? Which value?
So suppose there is a value 20. So then
Okay.
in which interval we will put that? I often get
Yes.
confused in this.
Yeah, 20 you'll be putting. See, I was just talking about this, right? If you have 40, okay, you'll be putting it here. Okay, you have defined in such a way. See, that's more of a how are you defining your class interval. So we are dealing in such a way that whenever you are getting this 40, so basically we're starting with 30, but we are not including this 40 in this interval. We are starting with here 40 and we are going till 50, but we are not including 50 here. Okay, it is somewhat like 30, like this. Okay.
Okay, sir, I got it.
Open and close
Sir,
bracket.
if we are asked to find the median of it, how to find it for this case scenario?
Okay,
If
I'll
we had
go
one
through
or
that.
two more
Yeah,
rows.
I'll go through that. So
Okay,
let's
sir.
first of yeah.
You have to multiply.
Okay. So now let's start with the stem and leaf diagram. And this is pretty simple. Mostly, if you will asked about the stem and leaf, so the diagram will be given to you. Okay, and then maybe you'll be asked to calculate the median mode or or other things you'll be asked to calculate from the given plot itself. Okay, so so whenever you have been written any data point that has been written like 57, okay, or maybe 75, 86, 90, or maybe 102. So if you have been given this type of data set, so this data set can be end of, like, let's for example, this here we just took it 5 data points only. So you can just plot this stem leaf in such a way that so you have to write, first of all, you have to write in the form of a ascending order. Okay, so all those the one more thing is you have to, first of all, whatever the data set has been given to you, you just divide this as a stem and a leaf. Okay, so you just put it as a stem. So the leftmost part you just put it as a stem, or you can, in this way, the rightmost part you can just put it as a leaf, and the remaining portion will be putting as a stem. So for this all portion, this is leaf and this is stem. Leaf, stem, and this is also leaf. For you, the 10 is a stem. Okay, and if you have to plot it here, so you just start with 5 because 5 is the smallest one, and then we'll start putting all those numbers, all those stems in the ascending order. So 5, 7, 8, 9, and 10. Okay, and then again, so you don't have to put it like this. The next part you'll be writing in, so let's, for example, the other values are also there, 58, and then 55, 56. Okay, so now again here also you'll be putting in the form of ascending order. Okay, this is the way of pictorial, or just the way to how to plot this type of a data set has been given, whatever has been given to you. So you'll start with 55 because 55 is the smallest one, so you'll write it like this, 55, and then you'll put it 6, and then you'll put it 7 and 8. Similarly for 75 also, if you have a data set like this 71 and then 79, somewhat like this, so you'll be starting with 1 and then 5 and then 9. Similarly for 86, you'll just put it as 86, 90, and then for 102, you'll be putting like this. So this is the stem and leaf plot for the given data set. Okay, you just, for data set, you'll just put it all, you'll divide all those data set as a form of a stem and leaf, and then you'll start writing, you'll just in the plot, you'll just put all the stem in the ascending order and then leaf in the ascending order. Okay, so stem, for a stem you'll be going from up to down, and from the leaf you'll be going from left to right. Okay, and in this way you can just plot or show your stem and leaf. Okay, and this is pretty simple. In the exam, if they're asking you something, they'll just give you the plot, or maybe they will just give you the data set, and then they'll ask you which of the following 4 stem and leaf are correct corresponding to the data set
Sir, I have a
given to you.
question in this.
Okay.
I didn't understand this part.
Sir, like as like sir, the stem, sir, do we need to arrange it in ascending order as well, or it is like we can arrange it randomly?
No, you have to put it in the ascending order.
Like, sir, stem and leaf both should be in ascending order.
Both should be in the ascending order.
Okay, sir.
Okay, so that will help you to calculate the median, right? If you have been given to calculate the median, it will be helpful, right? If you're not putting in the ascending order, then you might be wrong in calculating the median, because median every time you have to calculate the 50th percentile or maybe the center data point, correct? So if you're not putting in the ascending order, you might get the wrong answer.
Yes, sir.
Yeah. So this is
So I'm sorry to interrupt in between, but I didn't know this part.
no. So stem and leaf is pretty simple. So whatever the data set has been given to you, you just divide those data set in the form of a stem and leaf. So basically, the rightmost portion or the unit digit value you can just think of as a leaf, and the remaining portion you can just think of as a stem. Okay. And now, if you have to plot it in the form of a stem and leaf, you will just start. You'll just draw a line, okay, and then whatever the data set has been given, data point has been given to you, you just put all those stems. So whatever the stems, so here the stem was 5, 7, 8, 9, 10. So you just put it in the ascending order from up to down, okay, and then you just arrange the leaf from left to right in the ascending order. Okay, this is what your stem and leaf is. I guess this is clear.
Yes, sir.
Sir?
Yes, sir.
Sir, I have
Excuse me,
I have
sir.
a doubt from a mock test. It's
Hello.
a question based on stem and leaf, but it's in mock test. So when can I ask you that question?
Maybe in the end we can discuss. Okay.
All right.
Sir?
All right. I'll
Yeah,
ask.
I'll have to finish the concept
Excuse me,
because
sir.
yeah,
Sir?
yeah.
Sir, even I have a doubt on computing a percentile.
Okay, percentile will deal, like we are just here.
I have
Like,
also a question regarding some questions in the PYQs. So after the discussion, I think
yeah,
we
after
can.
the discussion, maybe. Okay.
All right.
Sir? Hello?
Yeah, yeah.
Sir, what if there are decimal places in the
Yeah,
stem and
decimal
leaf?
places, fractional, all those things, irrational number, everything. If you are just dealing with those type of data sets, they'll define you how you have to take the stem and leaf. Okay, that's for example, if they have given the data set like this, so they will define that this point you have to take it as a leaf, and this part you have to take it as a stem, and then you can define it somewhat like this. Okay.
Yes, sir. They will give us key
Okay,
points.
so they will
Oh.
define you how are you going to take stem and leaf. Okay.
Yes, sir. They will give us.
So there will be a difference between 23 and 45 versus 2.3 and 4.5, right?
So this is what I am telling you. So if they are giving you the data set in the form of a decimal, so they can't mix you with the normal data point. If they're mixing you, like mixing the data point with the normal like integer, they'll define how you are going to take the stem and leaf. Okay.
Okay, so
Yeah.
then we don't need to worry about that.
You don't know, like you will be like, so they will define you. They can give you integer and then they can't define, but they can't mix both the things and then they
So
can
what
give
is
you.
interquartile range?
Okay, sir.
Yeah. So interquartile range, percentile, everything will deal with, but you'll have to wait for some time. Okay. So we, yeah.
Sir, if there is a single digit, what do we do about it?
So for single digit, you can directly take it as a leaf, right? So you just put it like if you have been given 0, 9, so you just take 9 as a leaf and 0 as a
No,
stem.
like it is written like 9 and
Written like 7 and nothing in leaf part.
What?
It is written in stream 7 and leaf is nothing, but it is totally empty in leaf part. What it means?
Can you write it in the chat box? Till that time, we'll just start discussing the next concept.
written 9 in the
please.
stem part and nothing in the leaf part.
Yes, sir. That's the thing.
What they have just written in the stem and nothing in the leaf.
Yes, sir.
Yes,
Okay,
sir.
then that can be an error. That you don't have to count it. Okay.
Those values don't exist in the data set. Just ignore
Yeah,
it.
that can be an outlier sort of things. I'm not like, maybe if you'll just send me the question, then I can be in the better position to tell you. But if just if you have been written somewhat like this, 5, 6, 7, and then 8, 9.
Shraddha, turn off your mic.
Mute yourself.
Shraddha, turn off your mic.
Okay, so what I was saying you, if you have been given somewhat like this, the data points 91, 2, 3, and then in between you have something like this 8, okay, and nothing has been written, you can just ignore this, okay.
Okay.
Yeah. So now
So we
we'll
will
start with
not
stem and
write
leaf
that
has been.
8, sir. We will
Sir?
not write that 8 in like leaves, like, sir, because 8 is like 0, it's we can just assume as 0.
That is what I'm saying. If you have been given somewhat like this, you just have to ignore it. Can be an error or something. Okay. You just hand. So this is what I'm saying. You can't get. First of all, you should not be getting. Okay. If you are getting, you just have to ignore. Maybe it's an outlier or something. Okay. Because
Okay, sir.
it can't be here. This is what I'm trying to say.
Okay, sir.
Yeah.
So I have a request. Can
Hello,
you
sir.
please ask everyone to have the doubts at the end, and you can go
Yeah.
with the
So
lecture.
I'll just correct.
Mute
So I'll
everyone.
just.
That's better.
So I have a doubt
Thanks.
regarding the stem and leaf concept.
What is the doubt?
Sir, suppose there are two number of same, suppose 99 is written 2 times, then what should you have to do in that case? We
Yeah,
have to
that's a
write
2 times.
9
Yeah.
twice.
So yeah, if 95 has been given 2 times, so you just have to take 2 twice, right? So if 95 is given twice, so you just have to take it like this. Okay,
sir.
so you can have an n number, the repeated number. Okay. Okay, I'll just mute everyone and then I'll start with
Can you please
descriptive
ask
measures.
everyone to ask the doubts later
Okay, sir.
at the end?
Correct.
Mute everyone.
Yeah, please everyone ask. I'll just mute.
Yes, sir.
Also disable the chat. I think there will be something coming out in the chat if you are blocking.
Disable the chat box too, sir.
Okay. Thanks everyone. I'll just yeah.
No, sir. Do not disable that box.
Okay, so what I was saying about till now we have discussed about the stem and leaf. Now we'll just go. So we have now dealt with some of the basics. We got the basic idea about the continuous variable and the discrete variable now, and how to organize those data points. Now we'll have to deal with how to calculate some of the basic, how to get an idea about whatever the data points that we have organized, the continuous data point or the discrete data variable or the point that we have organized. Now we have to get an idea about the descriptive measures. Okay, so are basically descriptive measures are the quantities whose values are determined by the data and can be summarized, okay, on a data set. So now we have to take about the descriptive measures that we can take it on the organized data points. So the data points or the chart that we have created, we have to calculate some sort of a things, right? So and these things can be, the first thing that you have to calculate or maybe can be is the measure of central tendency. And the second one is can be the measures of dispersion. This is basically central tendency. This basically means that some of the data points that you are already knowing. So mean, median, and mode. So this basically tells you the measure of central tendency mean that so one data, if you just need only one data to describe your chart or the data set that you have been given, okay, you just need only one data. How can you describe your whole data as a only one data point? So that can be your mean, median, mode. That depends on so how are you calculating? So mean, median, and mode. And then the measure of dispersion can be basically this generally indicates the variability, okay, or the variation in the data point from. So this is basically the spreadness in the data point, the spread of your data set okay. And this basically gives you an idea about the indicate the most typical value or the center of the data points in the only one. Let's start with the mean. You already know that. So this is basically the summation of all your data points that has been given to you upon the n. So number of data points that is available. So for this mean, so the sample and the population will be same. So many a times your formula basically get changed. For let's for example for the covariance or the variance, and whenever you are calculating the sample and the population is different. Here for the population and for the sample both the formula is same, right? And some of the features, so and you will be getting in the exam the questions from the features. For features like if you have been calculating the mean for a discrete data. So this exam, the formula basically the x type upon n. This is for the population and this is for the sample. Okay. So now if you have been asked about if you have been asked regarding if you have been asked about like if you are just adding the some constant C to each of the data points. If you're just adding C to each of the data points, what can be the impact on the mean? Okay, or you're multiplying some constant C to each of the data points, what can be the impact on your mean? So this type of problems is very likely to be asked in the exam. Okay, so I'll just start with some basic idea example. So for mean, so the mean, so the one thing is, if you have been given the data points directly, like the marks for some 10 students, so you can directly add the marks for x1 plus x2, somewhere like this, and x10, and then divided with 10, you will get the sample mean, or the mean for the marks, the mean of the marks of the student. Okay, now the second method or the second things can be of a group data point. So we have dealt with the discrete single value data, or you can say the discrete data point. Okay, so now here you can be given, so I told you, so your value was, so your chart that we have created in the starting was in this form, right? So where the values are in the form of 1, 2, so maybe the number of household, number of people that is present in the household. Okay, and then you can have a frequency, and then so frequency can be, let's for example, here it is 2, 3, 5, 1, somewhere like this. Okay, here it is the value. Okay, for this cases, for this type of cases, we will calculate what we have to calculate fi xi. Okay, so frequency, the number, which basically, if you will calculate the mean also, whenever you calculate the mean for this type of a data set, you basically, what will you do? So for one, the frequency number, how many times one is occurring? Twice. So you'll be adding 1 plus 1. Similarly, 2 is occurring thrice, so 2 plus 2 plus 2. Similarly, 3 is occurring 5 times, so you'll be adding 3 5 times. Okay, 3 plus 3 plus 3 plus 3 plus 3. Similarly, 4 is occurring once, so you'll be adding this, and then you'll be dividing with whole. So the number of terms that is present here. So now, if you, so to minimize, to overwrite this, so 1 you're writing twice, and then 2 you're writing thrice, and 3 5 times, and 4. So what we are going to do is, you will just multiply this value with the frequency. So how many times it is occurring? So twice you will be just doing it 2 into 1. Similarly, 3 into 2, 5 into 3, and 4 into 1. Okay, and then you will be added, because here also you are just adding all those values. So mean is basically addition of all the values that is occurring divided by the number of terms that is occurring. So 2 plus, so you'll just add all those values. So 2 into 1 plus 3 into 2 plus 5 into 3 plus 4 into 1, and divide with the number of terms that is available. So this is basically 5 plus 6, so 11. Okay, so the formula that comes here is summation of fi xi upon n. Okay, this is basically your mean for a group data, for wherever, for a discrete group data. Okay, now we'll deal with the second type. So the second type was what? Mean for group data that is continuous. Okay, so now here I already told you that here will be for the continuous data, you have just organized your data set in this form, right? You were having a class interval. You were having class interval, you were having the frequency. Okay, okay, now for this type of data set, let's for example, here I just randomly I'm just writing 30 40, then 40 to 50, then 50 to 60, so and 60 70. Let's for example, this was our continuous data points. We have just divided our, whatever the data point was given to us, we have just organized in this form of a data, like organized chart. Okay, now the frequency can be 3 6 10 15. Okay, so number of data point that is available from 30 to 40 is 3. This is some like 30 to 40, 40 is not included. Okay, similarly for 40 to 50, 50 to 60, 60 to 70. Okay, now this is a frequency. For this type of a data set, what we are going to do is, we are just calculating the midpoint. So we'll calculate the midpoint. Okay, and then so midpoint, you can just see in this type of a data set now, because we have n number of data points, we started taking we just we'll just, whatever the data point that is available between 30 to 40, we'll just consider that data point as the midpoint itself. So midpoint would be 30 plus 40 by 2. So this is 35. Similarly, 40 plus 50 by 2 is 45. And this is 55 and this is 65. Okay. See, what we are going to do is here in this type of a case where let's for example, your data set was 31, 32 and 33. Even though the data point was 31, 32, 33, we are just considering all those data point as 35, 35, 35. Okay. So that's why in this type of a case where you have been given the group data point for the continuous data. Okay. And then the interval is given like this, 30 to 40 and 40 to 50, 50 to 60, 60 to 70. Whatever the data point has given, you have just categorized or just put it, you just counted out how many data points are present between 30 to 40, just put it as a 3, 6, 10, 15. Okay. And now you just took it as a midpoint, like you just considered all those data points that are present between 30 to 40 as a 35, all those data points which are present between 40 to 50 as 45. Similarly, 50 to any data point that is present between 50 to 60, you are first considering as a 59. Okay. Similarly, for 60 to 70 also, you are considering as a 65. And then what you are doing, the same thing, Fi multiplication with Mi. Okay. Similarly, you will calculate 35 times 3, then 45 times 6, then 55 times 10, and then 65 times 15. You'll just add all those values and divide with the number of values that are present. So you'll just count the frequency number. So this is 25 plus 9. Okay. So 34. You just do the summation. So summation of Fi, Mi divide upon the number of terms that is present. That is for this particular case, this is for 34. Okay. So this is your mean for this case. Okay. I guess this is clear for the continuous data, for the group data points, for the continuous data point as a group. So you have organized your data point in the form of a chart and then you have calculated the mean like this. Okay. Now I'll just deal with some of the basic features for a mean. So for mean, either, so two things can happen. Either you are adding constant in each of the term, then what is the impact? So earlier you were doing the summation. So doing the summation of xi, okay, and then upon n. This was your mean. Now you have added constant c to each of the terms. So if you are just adding, let's for example, you are having only 5 terms. Okay. So basically x1 plus x2 plus x3 plus x4 plus x5 upon 5. So now you're adding constant c to each of the terms. So x1 plus c, similarly x2 plus c, similarly x5 plus c also upon 5. So now you have 5 times c also. So summation of xi is same as earlier plus 5 times c upon 5. Okay. So now what is happening? So this is as early. So xi plus 5 is already present here. So that is basically the mean plus 5c upon 5. So now your new mean, so basically your new mean is old plus c. Whenever you have been asked about this, so if you are just adding the constant c to each of the term, your mean is also getting shifted 5 times. Okay, your mean is also getting shifted to that particular value itself that you are adding to each of the term. Okay, similarly for the multiplication also, your new mean will be, so whatever the earlier, if you're old times 5. Okay. So if you're just, this is for the adding, this for the multiplication. Okay. Now let's deal with the median. I guess I'll just unmute for some 2 minutes. And if you have a doubt till now, you can just ask me, or maybe I'll just go through. Okay. I guess this was simple. Yeah. Is this clear to you, everyone?
Sir,
Sir?
Yes, sir.
Sir,
So I
sir,
have
I
a
will.
doubt, sir. In case of adding a constant to the mean, we have to add the constant in the older mean also. But in case of multiplication, what we have to do?
You have to multiply that constant to the older mean.
Just like the addition, in case of multiplication also we have to do the same thing. We have to multiply the constant.
Can you give an
Yeah.
example to perform this?
See
Okay,
what?
sir.
Let's for example for 10, there was a marks for 10 people. So you got so for 10 people you have calculated the mean. Okay, so the calculated mean was basically mean was the summation of the marks for all the 10 people upon 10. Now what happened is you have been told that that marks was out of 50. Okay, now you have to extrapolate that marks and put it as 100. So that means you have to multiply all the marks of the student by 2. Okay, and then calculate the mean. Or you can directly, what you can do is whatever the mean you have got, directly you can multiply with 2, you'll get the same mean. Okay, I'll just give you one example. See, let's for example there are only 2 people. Okay, so and that marks is m1 equals to 10 and m2 got some 15 marks. So now the mean would be what? So mean would be 10 plus 15 by 2. Okay, so this is basically 12.5. Now what happened is now you are multiplying each of the marks by 2. So 20 and then this is 30. Now if you have to calculate the mean, would be what? 20 plus 30 by 2. Basically that is 25. Either you would have done you have multiplied each of the term by 2 and then you have calculated the mean, or you can directly multiply the mean whatever you have got earlier and by 2 and then you will get the new mean. Is this clear to you, everyone?
Yes, sir.
Okay, let's move to the next part. Now how to calculate the median. So median is pretty simple. So median is basically the 50th percentile data point. Okay, so this is basically the 50th percentile data point. So for this case, if you have an odd number of data points, okay, or odd number of variable that is present to you, or the cases, or the even, it can be even or the odd. So the data point that has been given to you can be even or odd. So whenever you have an odd number, so the number of observation that has been given to you is odd, then the mean will directly be the middle of the ordered list. So to calculate the median, sorry, not mean, this is basically we are talking about the median. For the median basically is the 50th data points, or you can say whenever you are arranging, so you first have to arrange those data points. So you have to arrange those data points in the form of ascending order. Okay, and now if your data point, the number of observation that you have been given is odd, then you can directly put it as a center data points or the 50th percentile data point, or we can say that n plus 1 by 2th observation. Okay, so if you have a odd, basically directly the middle data point would be the your median. And for the even data points, if you have been given the even data points, so now what you will be doing is n by 2th data points plus n by 2 plus 1 data points. So then n by 2 data points and the next data point, you have to take the average of those two. Will be having the median. Okay, is this clear to you? This is simple, right? Okay, and in this case also for the median also, for median also, so in median also you can be given like you are adding constant c, or you are multiplying constant c. Okay, multiplying constant c here, or you are adding constant c here. So in this case also, whenever you are adding the constant c, your new median will be, the new median basically will be old plus c. Okay, and your new whenever you are multiplying the constant c with each of the term of the median also, because now you have multiplied this with some constant c, maybe you have extrapolated the data point. Now the new median also, because now the each data point has been extrapolated, so your new median also will be basically the new median will be the old, I'm not talking, this is not mean, this is median. Okay, so now your new median will be old median plus constant c. Whenever you are multiplication also, so the new median now also will be the old median multiply with the constant c. So the same thing happening for the median also. Is this clear to everyone?
Yeah, sir.
Okay. Now one more
Yes,
thing.
sir.
Yeah. So one note that you can make it as a mean basically is sensitive to outlier. Is it? It is. So you can be asked in the form of a MCQ also. It is sensitive to outlier, but median basically is not that. It's not much sensitive to outlier. Okay. You can just, this is an important concept that you should be knowing. Okay, you can be asked in the form of a MCQ or maybe in the MSQ if you have been asked. Okay, so this is basically whenever you have an outlier also your mean will get affected. Like I'm just giving you some example. Let's, for example, you have been given a data points 1, 2, 3, 4, 5. Okay, and now because of some outlier, this outlier is somewhat like this 1000. Okay, now you can see that whenever you calculate the mean, this will get impacted a lot. So earlier the mean was 1 plus 2 plus 3 plus 4 plus 5 upon 5. Now the mean is 1 plus 2 plus 3 plus 4 plus 5 plus 1000 upon 6. So your mean is getting affected a lot. Now if you will calculate the median, so earlier the median was what? The center point. So now also that median would be what? Median would be 3 plus 4 by 2. So this is basically 3.5. It is getting impacted but not much. But you can see that mean was impacted a lot. Okay, that's why it is said that mean is basically very sensitive to the outlier. Okay, now if you'll just go to the mode is pretty simple. This is like the most frequent data point. So whatever the data point that is most frequent, okay, that is basically your mode. If you have been given something like 2, 12, 5, 7, 7, 6, 3, something like that. So the most frequent data point is your mode. And here also, if you are adding some constant C, so if you are adding the constant C, the mode will also get added by C. And if you are just multiplying the constant, multiplying each of the term with some constant C, so your new mode also will get multiplied with that constant itself. So here also you can write it as new mode basically is the old mode plus constant. And similarly for the, if you are multiplying, so adding constant C and then multiplying constant C, here also old mode into C. So here also it will be the same thing. Now we'll deal with the measure of dispersion. So in the measure of dispersion, you will deal with in the measure of dispersion, the first thing that you will deal with is the range. Range is like whatever the data set that has been given to you, you just take out the maximum data point that is present there and the minimum data point. So basically the range is simple. Maximum minus minimum is your range. Okay, this is, I guess, very simple. Now the second thing that you'll deal with is the variance. Okay, and the variance is basically the spreadness of the data points. So variance generally means the variability in the data set. Okay, how your data point is varying from the mean. Okay, so that basically is called as a variance. Okay, for this variance you'll be having two formulas that you already know, that either you calculate for the sample variance or you calculate for the population. Okay, so for the sample you have the formula. This is like summation of how deviated your data points from the mean. So basically this is mean. For each data points, you xi minus mu, a whole square upon n minus 1. And for the population, the summation xi minus mean, how deviated is your data point from the mean, and then upon n. So here the number of the whole number you will be counting, and here the sample, for the sample variance you will be counting as a n minus 1. Okay. Okay. So, and here also for the variance also, for the variance also, maybe you can add some constant. Now if you are adding some constant C to each of the data points. So now if you are adding some constant C to each of the data points, here for the variance it will not get impacted. Okay, because see, in this variance what are we calculating? The how the data point is varying from your central value. So now your central value is also getting impacted. But so see, in the variance what is happening, you are just calculating the summation of xi minus mu का whole square upon n minus 1 or n. So it depends on what you are calculating, the sample or the variance. Okay, let's for example for the sample. Here you can see that if you are adding c constant to each of the data points, okay, so the mean is also getting impacted. So now if mean is also getting impacted with the c, so now the new mean would be old mean plus c. So and the values is also getting impacted with c. So now the c plus minus c. So the c will get cancelled. So at the end, the variance will not get impacted. So if you're adding some constant c to each of the terms, so the variance will not get impacted. So the variance would be new will be same as the old one. Okay, so this is important. For the variance, it is not getting impacted. For all the other cases, it was getting impacted. Now, if you are multiplying some constant c, so now if you are multiplying some constant c, so here it will get impacted. So you here, so new mean would be new sigma would be sigma square times old. So this will be, and then multiplication with c square. So if you are in the variance, if you are adding some constant c to each of the term, so the variance will not get impacted if you are adding some constant c, because this mean will nullify that c. Now if you are multiplying some constant c to each of the term, so now your variance would be c square times the old variance. Okay, is this clear to everyone?
Sir,
Yeah.
can you go up a little bit? In which like you wrote the formulas for sample and population variance. Here isn't the formula for sample variance is xi minus x bar the whole square, or do they mean the
This
same?
basically mean only. So this you write it as x bar.
Okay, so thank you.
Yeah, so mean basically you write it as a x bar or you just write it as a mu. So both are same. Okay. Yeah.
Sir, in variance, when adding constant, the new value will be also a function of constant, right?
So the new, if you are adding some constant, then there is no change in the variance because you already know that. So see, let's for example, the xi will get changed to what? Xi plus c, correct? And mu will also get changed to mu plus c, right? So now if you just do this, you'll just try to, if you just try to see that how deviated is your data point from the mean. So you will see, you will do something like this, right? So this is getting cancelled. The c will get cancelled, so you're left with xi minus mu itself. Correct? So that's why there is no impact on the variance if you are adding some constant c to each of the term. But it will get impacted if you are just multiplying the with c. Because here, because for the multiplication, xi is also getting c times minus mu is also getting c times, right? And this is a square. So if you will just take out the c constant outside, so it will be c square minus xi minus mu ka whole square. So that's why the variance will get multiplied with c square times. Is it clear? Now for the standard deviation also, the same thing will happen. So for the standard deviation, what?
Sir, in the variance before formula, the sample variance, in that which mean will we use, sample mean or the population mean?
The sample mean and the population is same, right? Mean is same for sample or the variance, both. Okay. For the population or the sample, the mean is same. Okay. Let's for the standard deviation. Standard deviation also can be having two formula: the sample standard deviation or the population standard deviation. Okay. Here also the same thing. So the only thing is just whatever the variance that you have calculated, you just take the square root of that. That basically is your standard deviation for the sample one. Similarly, for the population also, whatever you have calculated, the variance that you have calculated earlier, right? So you just take out the square root of that, you'll be getting the sample standard deviation. And here also, if you're just adding some constant c to each of the term, the standard deviation will not get impacted as your variance is not getting impacted. And if you're just multiplying some constant c here, as your variance was getting impacted c square times, so the standard deviation will get impacted by c times only, because here your new standard deviation would be what? C square times variance, and if you'll just take out the c outside, so you'll be left with c times variance. So this is basically impacted by c time. Okay, is this clear to everyone?
C square or C, sir? Only C multiplied by C.
No, what I was saying is variance, your variance will get impacted if you are multiplying some constant C to each of the term, your variance will get impacted by C square times, but your standard deviation will get impacted by C times only. Okay? Is this clear?
Yes.
Okay. Let's move to the next part. Now we'll deal with the percentile. See, percentile is pretty simple. So in the percentile, whatever the data point that has been given to you, you just write it in some form of a whatever the data point that has been given to you. Okay, you just divide your whole data point in some sort of a 100 or 99 points. So you'll start with some 1 and then you'll go till 99, or maybe the last one is 100. Okay, you'll start it like this. So you start with 0 and then you'll go till 100. Now in between, if let's for example, this would be your 50th percentile, this will be your 25th, and this is your 75th percentile. So it's just an example. So now if you are dealing with nth data points, okay, so nth percentiles, okay. So what happens is it just tells you that if you are here and you are dealing with 50th percentile, it just means that 50% of your data point is lying on the left side and the 50% of your data set is lying on the right side. So you would have heard about somebody scoring 98 percentile. What does that mean is 90, if somebody is scoring 90 or 98 or 99 percentile, this means that 90 or 99, whatever he has scored, so that many percentage will be lying on the left side. That means so 98 or 99% of the people has not like performed so what so if I'm just saying you that 90 or 99 percentile somebody has scored, that means 98 or 99% of the data point or the student are lying behind that guy, and only 1%, that is the remaining portion, 1% is lying above him. Okay, so this is basically your meaning by you mean by percentile. Okay, and how do you calculate? So if you have been given a data point and been asked to calculate the 25th percentile or maybe the 10th or the 9th, whatever the percentile, if you have been asked to calculate, how will you calculate those percentile? Okay, so first of all, what you will do is you have been given the n, so the number of data points will be given to you. So n, let's for example, n itself is the number of data points, and now you have been asked to calculate the pth percentile. So whenever you have been asked to calculate the pth percentile, so this percentile is in the form of some percentage, right? So if you have been asked to calculate, let's for example have been asked to calculate the 25th percentile, so what the p value would be, you just divide this 25 by 100 and you will be getting the p value. So now you are left with np p as 0.25. What you will do is you will calculate np first. The first step that you should be doing is to calculate np. N is the number of term that is present and p is the pth percentile. So if you have been given the 25th percentile, the p value would be 0.25. After calculating this n times p, you can be getting a value in the form of an integer or a not integer. Okay, now if you are getting the value in the form of some decimal form, okay, so let's for example you get something like you got something like 15.6. okay, so now what you will be doing, you'll just take out, so the next data point, so the 16th data point will represent your nth percentile. Okay, and now if you are getting some exact value, some integer itself, so let's for example you are getting 17 itself, so what you will be doing, you will be taking out the 17th point and the 18th point, and then you will take the average of those two. Okay, that will be your nth percentile. Let's deal with one example. So you have to calculate the 25th percentile for the given data points, and the given data point is 68, 38, 66, 79, 61, 47, 68, 35, 70, and 58. Okay. So if you have to calculate the 25th percentile, the first step is what? You just count the number of data points that is present. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So your n is 10. And if you am asked to calculate the 25th percentile, your p is what? 0.25. Yeah, 0.25. Okay. So now NP value is what? NP is 2.5. Correct or not correct? It's correct, right? So now I told you, right, if you are getting something in the form of a decimal, your third data point. So that now if you are getting 2.5, even though if you have got 0.01 also, 2.01 also, you would have considered third point as your 25th percentile. So this is, so you'll consider third point as your 25th percentile. Okay? Is this clear? So what you'll do, so the first thing is you'll be arranging those data points. So you have to arrange those data points in the ascending order. If you just arrange this data point, it will be 35, 38, 47, 58, 61, 66, and then you are left with 68, 68, 70, and 79. So now if you have asked to third point would be your 25th percentile. So basically the 47 is your 25th percentile data point. Is this clear to everyone? I guess you're on. So you can just unmute yourself. You can just.
So,
Yeah.
if the digit after the decimal gets
I have
lesser
a
than
question.
So standard deviation.
0.25 came?
Yeah,
I have a question on
2.5.
standard variation.
Okay, so I'll just tell you why this 2 point. So whenever you will be asked to calculate any percentile, like 50th percentile, you have to, because it is in the form of a percentage, you have to divide that with 100 to get the p value first of all. Okay, and then multiply with the n, the number of data points that is present. Okay, so NP if you are calculating, and then depending upon the NP value, whether it's an integer or not integer, you will be getting your percentile. Okay, is this clear to everyone? Yeah.
Case of standard deviation, you told us about the case of multiplying with a constant, but what about adding a constant?
No, adding a constant doesn't impact your variance or a standard deviation.
Okay, sir.
Sir, can you write on table where you can mention that which is impacting, which is not impacting, like multiplication mean is impacting, or mode is not impacting, or the standard deviation is not impacting. Can you make just small table so like for us it
Okay,
will
I'll
be
just
easy
try
for
to make it. Yeah.
remembering? Yeah.
So this is basically add some constant C. Then multiplication with some constant C. Okay, so the first thing is just give me 1 second. I'll just so the first thing is mean so here if you are adding some constant C, so your new mean will be what? New mean would be 1 second. So if you are adding, new mean would be old mean. Give me 1 second. Hello.
Sir, you are audible.
Someone's mic is on. Can you please turn off it? It's really disturbing.
Yeah. Okay. Okay. So if your new mean would be what? Old plus C, correct? If you're multiplying here also would be what? Times C.
I use turn off your mic. I use turn off your mic.
Please everyone mute yourself, otherwise, yeah. So now here the new median, it's not new median would be what? The old times C constant. Here also it will be multiplication. So median multiply with this constant C, whatever was given here. Okay. Now the mode, the new mode. Here also whatever was been given earlier. So you were having some old mode plus constant C. Here also, if you adjust, so here new median. New mode equals to old mode times constant C. Okay. Now the variance. So there is no impact on this. And after multiplication, your new variance will be C square times the old variance. Here also no impact. Okay. Here the new standard deviation would be not C square, this will be C times. C times the old standard deviation. Is this clear to everyone?
Sir, you have again written C square.
Oh, sorry. C times. Here? Can we
Yes,
move to the
please.
next part? Okay.
Yes, sir.
Okay. So let's
Can you
move to the
summarize percentiles once again, sir?
percentile. Okay. So what I was saying about the percentile. See, if you have been given the data points, you are arranging all your data point in the ascending order from some, you're just arranging your data points. Now, so percentile you can just think of as you're just dividing your whole data points into some form of so you're starting with from 1 to 99. Okay, and this is your 100th data point, 100th percentile, and this is your 0th. Okay, so you're just marking 99, you're just taking 99 points and you're dividing your whole data point into 100 equal parts. Okay, and now if you have been asked to calculate, if you are just dealing with the percentile and then you have been given something like nth percentile. Okay, so now nth percentile, this basically means that, so here you will be having some, in the left side you will be having some data points, and in the right side you will be having some data points. So if you are just dealing with nth data points, or you can say that, let's for example, this with the maybe with the number you'll be able to understand it better. It is dealing with some 60th percentile data point. NP is 60th percentile data points. That means basically means that here behind you have 60% of your data point, and in the right side you have 40, the remaining portion. So basically this is 100 minus NP that was present here. Okay, 100 minus 40, and here it was 60 data points. So you would have heard about somebody is scoring 99 percentile in some exam. That means 99% of the data points or the student will be lying in the left side. Okay, and only 1%, 100 minus 1, 100 minus 99 will be in the right side. Okay, so this is your percentile. How will you calculate the percentile? If you have been given the data points, how will you calculate that? This is the most important portion. So the first step is to arrange your data points. So you arrange your data points, arrange the data points in ascending order. The second thing is to calculate. So you have been given N and you have been given P. Okay, so if you have to calculate the 50th percentile, you just take P as a 0.5. You have been given the N and then multiply with, so calculate NP. And now if you are calculating NP, you can get a value in the form of a decimal, or you can get directly integer. If you are getting a decimal value, so let's for example, you are getting 15.4. So you will just take 16th data point as the your percentile, nth percentile. And if you are getting something like 17, so if you are getting integer, then you will do 17 plus 18. So 18th data point and the 17th average you will calculate, and that will be your nth percentile. I just gave you one example where we were having where you have to calculate your 75th percentile, or let's, for example, you were calculating 75th percentile. So for the 75th percentile, you just take P as 0.75. So in the same data point that was given here, if I have to calculate the 75th percentile, so N is 10 and P is 0.75. So now you have NP as 7.5. So as it is in the form of a decimal number, you will just take 8th data point as the 75th data point. And so first, second, third, fourth, fifth, sixth, seventh, eighth. So 68 will be your 75th data point. Is this clear to everyone?
Yes, sir.
Okay, let's move to the next one. So quartile. So quartile is like same, like you don't have to, like the percentile, whatever we have discussed. Okay, so quartile is all the 3 points. So basically the first quartile, second quartile, and the third quartile. That you already know that this is a 25th percentile, this is a 50th percentile, this is a 75th percentile. Okay, so how do you calculate that? So you can calculate it, right? You have, if you have N, you just take P as 0.25. For this case, you'll just take P as 0.5, and for this case, you will take P as 0.75. Okay, the same thing is 5 number summary. 5 number summary is nothing else. You just start with your minimum data point, whatever has been given to you, first percentile, second percentile, third percentile, and the maximum data point. Okay, and IQR is basically the difference between the 75th percentile and the 25th percentile. That is basically your IQR. Okay, so the only thing that we should be knowing for the exam is how to calculate the percentile. If you have been asked to calculate the 25th percentile or 50th percentile or 75th percentile, you should be knowing how to calculate those things. Okay, and maybe they can ask you what's the value IQR. So IQR, if you are able to calculate the 75th percentile and 25th percentile, you just do the sum, like subtract it, you will get the IQR value.
So what if
Okay?
it comes in decimals?
I told you, right? If you are getting in the form of a decimal NP value, you just take the next integer. If this is 15.6, you'll take as a 16th. If it is 0.7, you'll take as the first data point. If it is 1.01, if it is 2.3, you will take the third. Okay, is this clear to everyone? Let's move to the next week. So week 3 is done. We'll move to the 4th week now. I guess this is clear to everyone. So we can have a break. Yeah, go ahead.
So what is the difference between sample standard deviation and sample variance?
Sample standard deviation and sample variance. So how do you calculate? See, in the variance, what was the formula? So whatever the unit C, what happens in the variance, you are calculating how your data point is varying, or basically, see, both of them are used to calculate the spreadness of your data point. Okay, in the variance, you are just doing the square and then dividing with the number of terms that it was present. In the standard deviation, just to negate the unit, you just took the square root of the variance to get the standard deviation. Okay,
so we have to divide it by n minus 1, no?
No, you were asking about the difference between variance and standard deviation, right?
No, sample variance and sample standard deviation.
So in both the cases, you have to divide by n minus 1 only.
Okay.
Yeah, so for the sample standard deviation also, for the sample variance or the sample standard deviation, okay, you have to divide. Here, you just have to summation of xi minus mu whole square upon n minus 1. Here, the same thing, summation of xi minus mu by n minus 1. Okay?
Okay, sir.
For the population, you divide it with n. For the sample, you divide it with n minus 1. Okay, let's move to the next week. If you have any...
In this formula, the mean is the sample one or the population one?
For the mean, for mean sample and the population both are same.
Okay. Sir,
Yeah.
so can we take the 50th second quartile as a median, sir?
Yeah. 50th percentile, you just take it as a median only. Because median we have already did. Median is basically the middle data point, right? And 50th percentile is what? 50% is lying on the left side, 50% of your data is lying on the right side. So that's why you can consider this as a median. 50th percentile data point, you can consider as a median.
Okay.
Yeah.
Thank you.
So I'll have a sip of water, so you can have a break for 2 minutes and then I'll start for the next week. Okay. Okay, so let's start with the next week now.
Sir,
Yeah.
sir, can you clarify one doubt for me from graded assignment week 4?
Even I have one.
Yeah, week 4 we haven't started yet. Yeah. So week 4, I'll just discuss the week 4 concepts in a brief. Okay, we'll not be going in. So we'll try to discuss all the concepts in half an hour. Okay, for week 4.
So when can I ask my doubt of week 3 graded assignment?
Yeah, in the end only after finishing. Let me finish the. Otherwise, it will go because you have a session from 8 for maths also, right? Okay. So for week 5, so in week 5, we are just dealing with how if you have been given two variables, that can be, one can be categorical, one can be numerical variable, and how are those associated. Okay, this is what we are dealing with. Okay, in week 4, we are just dealing with the association between two categories. First is like the first thing that we are dealing with is the association between two categorical data point, categorical variable. Okay, so there can be, so there are basically, so this generally, so we'll deal with the other things also. We'll just start with the first one. So association between two categorical variables. So variable that has been given to you is in the form of a category. Okay, so there can be different type of categorical variables. So some can be given as like a gender or so that can be, or maybe somebody is having some disease. Okay, so whether it is in the form of type 1, type 2, type 3 disease, so those can also can be considered as a categorical variable. Okay, so what happens if you have to calculate, if you have to check whether the two categorical variable that has been given to you is associated with each other or not. Okay, so let's, for example, we'll start with one example, and I guess the same example that has been dealt in the exam, like in the lectures also. You have been given a data point in this form. So you have a data points like, so categorical data as a gender, and then the other thing is having a owning a mobile phone. Okay, so this can be no and yes. Okay, this is like a total. And here it can be male or female. Okay, so now we have to check whether is there any relation, whether if somebody is owning a phone, is there any for a male or a female, is there any large gap between them, or is there any association between the two category, whether somebody is having phone with, so is there any relation between that? So if somebody, if you have been given this type of a problem, like if you have to check whether is there to check whether there is any relation between somebody owning a phone and a gender or not. Okay, so there can be a there can be, you can be given this type of a problem. Okay, and then you have to associate whether this is correct or not. Okay, so let's, for example, you have been given a data points like this. Here 10 is been given, 34, and then you have 14, and then you have 42. So basically this is 44 and this is 56. Okay, the total number basically you can just count it as 24 here and 76 here, and the whole number as 100. So out of 100 data, 100 observation, 44 out of them is a male and 56 is female. Okay, now you have to check whether is there any association between these two categorical variables. So the first categorical variable is the gender, and the second is the owning a phone. So if somebody is owning a phone, that means yes, and if he or she doesn't, that means no. Okay, so now we have to check whether there is a relation between those two or not. So the first thing that you should be doing is to calculate. There is some basic idea, like some basic idea about this type of a plot, or this type of a diagram that has been given to you. Okay, so you have to calculate the, maybe you can calculate the row frequency, row relative frequency, or the column relative frequency. Okay, if if both are almost same, so if both are almost same means if you are just calculating the row relative frequency, and if the values that you are getting is almost same for all the cases, then you can directly say that there is no association between two categorical variable. What does that mean? See, if you are just calculating the row percentage, okay, or you are calculating the row frequency, so that means out of this female, so out of this male 44 male, how many are owning the phone? That means 34 upon 44 is owning a phone, and 10 upon 44 is not owning the phone. Similarly, for the female, 14 upon 44 is not owning the phone, and 42 upon 56 is owning a phone. So now if you calculate the percentage, we will be getting somewhat like this. For this case, we will be getting, for this you are getting somewhat like 23%. Here you are getting somewhat like 77%, and here also you are getting 23 or 24%. Here also you are getting 76%. Okay, so now you can see that
female no also should be 56, right? 14
what?
divided by 56. Female no. 14 divided by 56 should come, right?
Correct. So it should be 14 divided by 56. Okay. Now if you'll calculate here also, so now we can see that. So now we have calculated the row frequency, and you can see that wherever the information was given as a male and a female for some 100 observation, and you can see that out of, for the male also, around 23 to 24% are not owning the phone, and around 26 to 77% are owning the phone. Similarly, for the female also, you can see that around 23 to 24% is owning the phone, not owning the phone, and 76 to 77% is owning the phone. And if you see for the overall data also, it is around 24 upon 100. So 24% of the data point or the observation is not owning the phone, and 76% of the observation is owning the phone. So you can get an idea from here, right? So what you're getting, irrespective of the gender, the irrespective of the gender, you can see that 72 to 76 to 77% of the people are owning the phone, and 25 around 25% is not owning the phone. So you can get an idea, right, that the gender is not impacting the ownership of the phone, right? Whether it's a female or a male, the ownership is not getting impacted, right? from this observation, you can get an idea that there is no association between these two variables. Is it, are you able to get it or not? Did you understand this?
Yes, sir.
Okay. Now let's move to the next part. So there can be, so in the similar fashion, so there can be, so either it can be row relative frequency or the column relative frequency. If all are same, then you can just assume that there is no relation or there is no association between these two variables. But if you are getting a different like percentage, let's for example, for the same case, if you would have got the percentage somewhat like for the male, if you are getting somewhat like 40%, and for the female, if you are getting somewhat like 70 or 80%, then you can say that the gender is affecting the ownership of the phone. So if somebody is a female, there's a high chance that she is having the phone. Okay, if the percentage is different, but if the row frequency or the percentage that you have calculated is same for both the cases, then you can say that there is no association between these two variables. Okay, so now let's move to the next example. Similarly, there are some examples, I guess, that has been discussed in the lecture regarding somebody like income. Is there can be two different categorical variable like the income. So now like except this render, now we can discuss with the help of the income level also. So if somebody is lower belongs to a higher income group or a lower income group or a medium income group, so is this impacting the ownership of the smartphone? So there can be an example like that also, where both of them are categorical variable. Like the first one is the high, low, medium income group, and the other is the ownership of the phone. Okay, so there also, if you have been given the chart, you can just get an idea by calculating the row frequency or the column frequency to get an idea whether there is an association between those two or not. If the percentage that you are calculating, row frequency or the column frequency, if both are same, you can directly say that there is no association. But if those are different, then you can say that there is an association or there is an impact of somebody from the higher or the medium or the lower group is having the phone or not. Okay, so you can be given this type of a diagram, and then you can get you can be asked to calculate some sort of a percentage, or you can be asked whether there is an association between two variable or not. Okay, I guess you will be able to calculate that. Okay, so now, so for the categorical we have discussed. Now let's move to the association. Between two numerical variable. Okay, so for the two numerical variable, we have some of the some of the methods. The first one is to draw a scatter plot. Okay, so you can be given two different types of a numerical variable like height or a weight, or a age or a weight, or age or a height. Okay, and then so you can, it's pretty simple. Like if you have been given two different types of a numerical variable, you just put one variable here in the x-axis and one in the y-axis, and then you can try to plot those two variables. If you have been given, for example, age and height. So this is 1, 2, 3, 4, 5, and then 75, 85, 94, 101, and 8. You can just plot it as it is. So here you can just take it as the age, and here you can take it as a height, and then you can just try to plot 1, 2, 3, 4, and 5. And here you can just think of as a 75, 85, 95, 105, and 110 or 115. And then you can just plot it as it is. Okay, this is a form of a scatter plot. So you just plot your given two different numerical variable, in one on the x-axis and one on the y-axis, and then try to just put your all your data point. Okay, this is your basically the scatter plot. Is this clear to everyone? Are you able to hear me? Okay.
Yes, sir.
Okay.
Yes,
Okay.
sir.
Hmm. Okay. So now after scatter plot, we'll start dealing with some other different like method to know regarding the association. Okay. See, in the whatever the scatter plot that you have, okay, there can be like a different type of scatter plot. So whatever the plot, the different type of plot. So the data point, basically the two different numerical data points that has been given to you, or two different types of a variable has been given to you. Numerical variable has been given to you. You try to put it on the x and a y axis. After putting it on the x and a y axis, you just see the scatter plot. You just check the scatter plot. In scatter plot, you can have a so basically you can have a different type of a scatter plot. Okay, so one scatter plot that you have plotted, so whatever the x and y that you have basically plotted, then can be in the form of like this. Okay, so this type of a data points can be there. This is basically, this you can think of as a data point that is described as a, so some of the basics thing that you should be knowing is what's the direction. So if you are plotting your if you are just plotting your data points, two numerical variable on the scatter plot, you can get an idea about the direction, how it is approaching. If you are increasing the value of x, how the y is getting changed. Okay, so this can tell you about the direction. Okay, whether the pattern that you are getting for the scatter plot, whether it is going upward or downward, those type of idea you can get it from the scatter plot. Okay, so the first thing that you can get an idea about is the direction. Okay, so the second that you can get it is the curvature, whether it's a linear or it's a non-linear. If this is in the form of this, you can say that this is a form of a linear. But if you have got data points like this, so okay, then you would not have told like this is a somewhat like this is not linear. Okay, so the curvature also you can get an idea from the scatter plot. Okay, or you can get an idea about the how the variance in the scatter plot also, whether it's a tightly packed, tightly clustered data points, all the data points are tightly clustered, or it is like not that tightly clustered, or you can get an idea about the outlier also. Okay, so if the data points, the scatter plot that you have plotted was like this, and then in between a data point is like this, then you can think of as this point as an outlier. Okay, so the scatter plot can give you some of the idea about the direction in which the your plot is, or you can get an idea about the direction, or you can get an idea about the curvature of the scatter plot, or maybe the how variability of the data point, or is there any outlier in the data points or not. So this all information you can get in from the scatter plot. Now the next thing is so the next thing that you can, how do you measure that? So if you have plotted the scatter plot, but how are you going to measure the association between the numerical variables? So basically we are dealing with two methods. So two measures by which we basically measure the strength of the association. So now you have plotted your scatter plot. Now you want to measure the strength of the association. How nicely both the variable and both the numerical variable are associated with each other. So for that you basically deal with the covariance, and the one more thing is the correlation coefficient. Okay, both are almost like one thing is the first thing that you are calculating the covariance. Covariance basically helps you to quantify. So this helps you to quantify the strength basically of the linear association between two numerical variable that has been given to you. Okay, so this is pretty simple. Okay, so covariance that you are calculating is not like is just telling you to, it just tells you the strength of the linear association between the two numerical variables. So first thing that what you have done is you have just plotted the scatter plot. So scatter plot generally gives you a basic idea about the direction curvature, whether it's a linearly like dependent or not, or the how is that curvature. Those type of things you can get an idea from the scatter plot. Okay, how whether it's a tightly packed data points or not. Okay, but how will you get an idea about the strength? Okay, so there the variance will help you. It's just basically helps you to measure the linear association between the two different numerical variables that is present to you. So the formula is almost same. So the formula that you have already dealt with, I'll just write the sample variance and the population variance, covariance. So this is basically for the population, the same thing, just that you divide it with n, x bar into yi minus y bar upon n. Okay, so this is your population covariance and this is the sample covariance. And what it is helping us, it is just helping us to know the strength of the linear. So it basically quantify or to measure the strength of the linear association between the two numerical variables that has been given to you. Okay, and what is the unit of the covariance? You can see that whatever, so let's for example the first numerical data, whatever the numerical variable was there for the first, let's for example the first numerical variable was given as a weight. So this is basically what this is in the form of weight. So whatever the unit of weight it is there, you'll be writing it as here. And let's for example the second weight, the second numerical variable was age or something, height. Okay, so here height is given. So the product of unit of both the cases, both the numerical variable will be the unit of the covariance. Okay. Okay. So this is the unit of the covariance. So I'll just give you an idea about, so now we have dealt with the samples scatter plot. We have dealt with the covariance. Covariance basically will help you to measure the strength of the linear association between two data points. If you are getting some, so see covariance, if you're the value that you're getting is some, and similarly, see the unit, we have already dealt with the unit. What happens is whenever you have some sort of a unit, so for this covariance you were having the unit in the form of, so whatever the numerical variable has been given to you, so there was some unit associated with that. Okay, so I was associated with that. So to compare two different like charts. Okay, so you need some, so whenever you're calculating the strength of something, so you should be needing some values in the form of unitless. Okay, to just make it as a unitlet, we started dealing with the covariance, like the correlation coefficient. Okay, where we'll just remove the unit. So the correlation coefficient, so both are almost same. So covariance also will help us to know the measure of the association. The measurement, like the both will help us to quantify only the linear, like what is the strength of the linear association between the two variables. But covariance, we were having a unit. Just to remove that unit, started dealing with the correlation coefficient. And here also the method that you are doing is same, xi minus x bar and then yi minus y bar. The only thing that we have started dealing is we have just divided with sx and xy. Okay, standard deviation of x and standard deviation of y. Now this correlation coefficient is now unitless. So this is unitless. Okay, and the value that you will be getting r is from what? R will be from -1 to 1. So r will be from -1 to 1. One more thing, whenever you are calculating a covariance, and if you are getting the covariance of this as a 0, that means what? it is totally independent. So x and y are totally independent. So the value of x is not impacting at all the value of y. So there is no association between the unit. There is no association between the numerical variable x and y. Okay. So now we are dealing with the correlation coefficient. So the correlation coefficient in the correlation now for the covariance, so whatever we were having, we were dealing with the covariance as the strength or the measurement, whatever you want to call it as a, that helps us to quantify the linear relationship between two variables. Now to make it as a unitless, we have started dealing with the correlation coefficient, because correlation coefficient was unitless, and this was useful to get an idea, more idea about how your data point is, how this basically help us to measure the linear association between the two different numerical variable. Okay, and it is basically derived from the covariance itself. We are just dividing the covariance that we have calculated to the standard deviation of x and y. Okay, now let's deal with, so there are some values, so I'll just write it down, some values. So whenever the r, so correlation coefficient that you have calculated is almost, so I'll just give you an idea about how are you going to define this. So whenever your r value is from, let's for example 0.75 to 1, okay, then you can say that this is very strongly positive relation, linear relation. Okay, similarly if your value is from 0.5 to 0.75, then you can say that this is also moderately positive. There is, so in between x and y, so for this case, for the first case, this is a strongly positively positive linear relationship between the x and y. For the second case, it is moderately dependent. X and y are moderately dependent. For the third case, if I'm just telling you, this is from 0.5 to 0.25, this is weakly positive relationship, linearly relationship. But if your data point is less than 0 to 0.25, okay, then you can see that this is like, you can see that there is an absence of like association, linear association between the x and y variable. And this you can think of as for the negative also. You can just write it as from minus 0.75 to minus 1, it is strongly. So here also the relationship is strong, but the thing is this negatively linear. So value of, if the value of one is increasing, the value of other is decreasing. Okay, here also there is a strong relation, like strong linear relationship between x and y, but in a negative way. Okay, so in the same thing, you can just think of as a from minus 0.5 to minus 0.75. It is moderately negatively linearly related between x and y. Okay, is this clear to everyone?
What it is 0.5 in that case?
Yeah, 0.5. Okay, 0.5. See, whenever you are so correlation coefficient, if you are getting from 0.5 to 0.75,
only
you can just
0.5. Answer is 0.5. If you not included 0.5 in that case.
Okay, if you are getting r as a 0.5, so whatever you can call it as a moderately positive linear. Okay. Okay, so we have dealt with association between two categorical values, two categorical variables. We have dealt with the association between two numerical variables. So for the two numerical variables, you will be calculating the covariance or the correlation coefficient, and that will help us to know that how positively it is related the x and y, like the two variable that has been given to you. And now the third thing is, the third thing is, whenever you have been given the association between a categorical and the numerical variable. Okay, so for those cases, you can just remember the formula. So, or you can just, I'll just give you an idea about how do you calculate. So if you have been given the data point, and now if you have the association between a categorical variable and a numerical variable, okay, so in this case there are some steps that you have to follow. Basically, So and one more thing, whatever we are dealing with here, so in this categorical we'll be having only two category. Okay, this is what we are dealing with. Okay, so let's, for example, you have a data points where you have been given the gender and the marks has been given to you. Now you have been asked whether there is any relation, any association between the marks and the gender or not. So this is basically a marks for some subject A, okay, marks for maybe for maths, and then you have been given the gender with their marks. So you have some observation, 10 observation, and out of that there can be 5 male or female or whatever the number it is, and then male, female, or some, all that information has been given to you. But the thing that you have to consider that the gender, like the whatever the category has been given to you, it should be in the only two categories should be present, and then marks has been given to you, and then you have to check whether is there any association between the marks and the gender or not. So if that means what, you have to calculate in this way. So the given, whatever the given data has been given, you have been given some data point where the mark sheet and the gender has been given to you for some students, and then you have to quantify, or you have to know, is there any relationship between the gender and the marks, whether one gender is getting more marks or not, or is it same for both the cases. So for those cases you have to calculate some sort of a correlation coefficient. And how will you calculate that? So first thing that you'll be doing is you have to put, for one gender you just put it as 0 or 1. So for male you can just divide your gender, like, so whatever the category, so you have two category, right? So just put one category value as at one place and the second category value as the second place, and then you just think of as a male as a 1 and female as male as a 0 and female as a 1. And then what is the formula? Basically the correlation coefficient that you'll be calculating, the R that you'll be calculating is what? I told you, you just divide the whole data in two parts. So for male you'll be writing at one place, and for the female you'll be writing at one place. And for the male you'll calculate the mean. Okay, so you'll calculate the mean marks for the male. Similarly you'll calculate the mean marks for the female also. Okay, and then for the marks you will calculate the standard deviation, that is basically standard deviation, and then you'll be dividing with P0 and P1. P0 basically is the proportion of male, and P1 is the proportion of female present in that data set. Okay, so this will help you to get an idea about whether there is a association between the gender and the marks or not. Okay, so this formula I'll just write it again. Mostly if you just know the formula, that itself is sufficient to solve your question. Okay, in the exam you'll be getting very simple question if you are getting from this portion. Okay, okay, this is the formula that will be calculating for the correlation coefficient if you have been given one category and the other as a numerical data point. Okay, and if you want to change it this in the form of a sample variance, that also you can calculate it. So you already know that for the so if you want to write it in this in the form of a sample variance, okay, how will you write this? So you can write it like this, right? N times sigma square equals to what? N minus 1 Sx square. Now if I have to just equals to what? N minus 1 N Sx. Okay, you just put it here directly. So you'll get in the form of a sample variance. Is it clear to everyone? So we just discussed about the basic concept of week 3 and 4. All this formula I have written it here for week 3 and 4. Now if you have a doubt, you can just ask me. I'll just unmute everyone. You can just ask your doubts that you have.
Sir, please explain it with the example.
Sir, can you explain my doubt in graded assignment of week 4?
Sir, can you explain the
Sir, can you explain covariance
Sir,
again?
can you explain that what is y0 and y1 please? One more time.
Okay.
Sir, are we going to have the doubt classes sometime later, because there is going to be a math class as well?
So I guess one more session, I don't know whether it has been scheduled. One more session is there.
So sir, we can decide or discuss
Hello, sir.
question in that
Yeah, yeah.
session.
So could you
Right,
just
sir.
share that the slide where you show the impact on by adding and multiplying a constant? I just want to take a screenshot.
Which one? Which slide?
Where you are showing the impact when you add or multiply a constant.
You
Okay.
created a table. It's a table.
Sir, in binomial correlation, in the technical lecture, there we divide it with the deviation.
What?
Binomial correlation divided with deviation.
Divided with variation. Maybe you can write
Deviation.
standard deviation.
Yes, sir.
Hello, so am I
Yeah, you
audible?
just divided with the, yeah. Is this slide is done right? I can go to the last slide, right? Okay. So what I was saying is this. Yeah. So this formula, which formula you're talking about? This
Yes,
one,
sir. Yes,
right?
sir. This formula. In the first
Yeah,
formula,
this,
there is a sample. There is a deviation, not a variance.
this is standard deviation that you calculate for the numerical data points. So this
Yes,
is
in the bracket formula, sir, there is a
yeah, go ahead.
deviation, not the covariance.
Is it
This
the
is
population standard deviation or
this is the population standard deviation. Yeah.
Okay. Thank you.
So this is, see, if you have to calculate in the form of population, and this, if you'll just put it here, sigma x, if you'll just put it this value, it will be in the form of a sample standard deviation. Okay. So if I'll just write it
Okay,
here.
sir. Can you explain this y0 and y1?
Okay, I'll just give you one example. Let's deal with, there is a marks for 10 students. Okay, maybe for marks for 20 students that has been given to you. So this is gender. Then you have marks. So the first student, maybe female, the marks she got is 71. Female, 67 marks she got. 65 she got. Okay, and then similarly male. So you got 69 and 75. Okay, now you just divide it as I told you, right? You just put it as female as 1, 1, 1, and this is 0, 0. So we were having only 5 students. Okay, and we were having only 5 students. So you just divided the whole data set as this will be your y1 and this is your y0. Now you can calculate the y0 mean, right? So how will you calculate this? The formula would be what? Y0 minus y1 mod upon sigma x times, right? So what should be the value of p0? What is the ratio of 2 upon 5, correct? Similarly, p1 is what? 3 upon 5, right? You can calculate the mean. So you can calculate the mean 69 plus 75 upon 2, correct? Similarly, for y1, you can calculate 71 plus 67 plus 65 upon 3. That will be the mean y1, okay? And sigma x also you can calculate for this 5 values. Okay, so standard deviation, you can calculate the population standard deviation. If you'll just put all those values, you'll be getting the value of 5. Is this clear to everyone?
Yes.
Yeah.
Sir, I have a doubt.
Please repeat it.
What?
Sir, I have a doubt.
Where?
Regarding standard deviation.
Yeah, what is that doubt?
How standard deviation is affected by outliers?
Okay, so this is simple, right? So if you have been given standard deviation, so let's, for example, see, you have just calculated earlier, you calculated the standard deviation, okay, from whatever the data point was given to you. Now you have outlier. Outlier, which type of outlier it is, whether it's a very large outlier or what. If this is a very large outlier, see, if you have just a very large outlier, so it will be impacted, heavily impacted, right? Your deviation. See, what do you mean by standard deviation? That is basically how your data point is getting variable, like how your data point is away from your median, like median, or you can say the mean point. Okay, this is what you calculate in the standard deviation. If your outlier itself, you are getting some data point as an outlier, right? So that means what? If you are having outlier, so you were having a data point like this. So all your data point was lying here, but some data point came here. So some form of outlier. So first of all, your mean will also get impacted. Okay. And your standard deviation will also get impacted. Are you getting me? See, you have some data points. So you were having 1, 2, 3, 4, and suddenly you got one data point as 10,000. Okay. So if you'll calculate, your mean will also get impacted. Your standard deviation will also get impacted from this outlier. Are you able to get understand this or not?
Yes, sir.
Yes, sir.
Yeah. Any other question that you have?
Sir, I have posted one doubt in the chat.
Yeah. So week 3 or 4, any conceptual doubt that you have? If you have to discuss anything?
Sir, could you please share this notes in the PDF format in the chat box?
This PDF you want?
Yes, sir.
Okay, maybe in the after the class will end, we'll just share it. Okay. Any other doubt that you have of the conceptual doubt from week 3 and 4? Anyone? Yeah, you can just unmute yourself if you have a doubt. Okay, can't. Okay, one second. Okay. Are you able?
Sir, I sent my question.
Yeah, sir. I have some
Sir,
conceptual doubt.
covariance is also affected by outlier.
Sir,
Yeah.
sir, I just sent my question in the chat box.
So one conceptual doubt is something. If mean has this problem of outliers, so why we are doing mean? Why we can't do directly the median and other things?
But
Why
what
we
if
are
mean is
going
getting impacted? Okay, what's
like
your question?
the mean is having the disadvantage, like it is getting infected affected by this outlier. So why we want to do mean calculation? Why we can't only do median?
No. See, so outlier is not always present, right? So outlier can be present because of some noise, or maybe in the data transmission there is some issues because of the noise, or some human error or all. It's not that it will always be there, right? And you can't just skip those process itself. If something is bad, like some outlier for one or data point, so for some, so see, if you have a data point, whenever you'll just clean your data points, at that time you'll try to check for the outlier, and if you are able to check for the outlier, you'll be easily, you can remove those outlier, right? It's not that you just skip those methods itself. Mean is a very so the central tendency, mean is one of the method to just get an idea about the whole data point. Okay, you can't just skip the mean. Okay,
means for example, in a live streaming, if I'm getting some glitches, so that is kind of a different results, kind of outliers. So you mean to say there should be some pre-filtering before actually
correct.
broadcasting the okay.
Correct.
That pre-filtering will remove the outliers, and then we can do if there is a mean in next algorithm, there won't be any impact on that mean because of we are doing pre-filtering of the
correct.
Okay.
Sir, one doubt.
Yeah, go ahead.
Sir,
Yeah.
Sir, I posted my question, sir. I have been waiting for
Yeah,
so
range
long.
will get impacted from the outlier. So whoever was asking, range will get impacted from the outlier. Okay.
Yeah,
Sir,
sir,
in
regarding outline.
sir, I sent my question in chat box. Once can you see that, please?
Excuse me, sir.
You can just tell me the question number. Which question number you
Excuse me,
want me
sir.
to solve? Yeah.
Sir, my question is on graded assignment, sir.
Graded assignment, which question? So somebody has posted about somebody's the problem relate. What can you say about the linear
Sir,
relationship between the 1 second? Dipans has asked some question. What can you say about the
Yes, sir.
linear relationship between the sales of OnePlus and BBK Electronics? Okay. So
yes,
this you
sir.
can, so whatever the data point has been, so whatever the correlation coefficient that you are getting, okay.
Yes, sir.
So depending upon that, you can get an idea, right, about the weak, positive, or whatever it is.
Exactly, sir. I'm getting R is equal to 0.496. Based
Okay.
on that, it should be weak and positive. Even in the answer range of the coefficient, if you see previous question, they have given it as 0.47 to 0.53, which means any of those answers is correct. So
No.
they should also weak also as correct option, weak and positive. That is my doubt.
No, so what's your doubt basically? What's the given answer is not correct or what?
Sir, answer they have given weak and they have given moderate and positive should be the correct options. I think weak should also be the correct option because if you see the previous question where they asked to find the correlation coefficient, that answer can be 0.47 to 0.53. If someone gets the answer as 0.48, they will take that correlation only, and based on that, they'll keep the option weak and positive. So either both of them should be wrong or even weak should be a correct option.
Okay. So for that, I'll have to calculate the value of R, whether you have calculated the R correctly or not. That we have to check it, right?
Yes, sir, we have to check it, sir. Do you have the solutions?
What?
Solutions, sir, of the graded assignment solutions.
So see, if we are, so whatever the value that I have told you, if the R value is from 0.75 to 1, that is strong, and then from 0.5 to 0.75.
That I understand, sir. That is not the doubt.
Then what's the doubt?
Sir, if you see the previous question of that, sir, where they asked what is the correlation coefficient?
Okay, so what was the correlation?
Sir, I got 0.49, but they gave that the range is between 0.47 to 0.53. Anything can be correct.
Okay, so that's why they have given the answer as a moderate, I guess.
Yes, sir. But if someone gets 0.48 or 49 as the answer of correlation coefficient, so that is correct based on the previous question. And then in the next question, again, they are saying that weak is wrong. But 0.48 or anything below 0.5 should be considered as weakly relation, right, sir?
Sir,
Yeah, I can understand. See, but in the exam there won't be any problem that will create a confusion. I can understand that what you're trying to say. Maybe so you're trying to say that some of the people can get value as 0.51 also. But if somebody is getting
Yes, sir.
0.51, that will be a moderate. But if somebody is getting 0.49 or 0.47, that will be a weak. Right?
Yes.
This is what you're trying to
Yes,
say.
sir.
Yeah. So
Yes,
I
sir.
can assure you that in the exam you'll not be getting this type of confusing problem. Okay. So it will be a
So,
clear,
sir, this
so it will
option
be
will
a
not be
clear cut.
changed.
It will be clear cut like somewhat like 0.8 or something like that, where it is very strong. So very strong relation, a linear relation between the x and y will be there. Okay. So you'll not be getting question in the exam.
Actually, we need to plot the scatter plot, sir, to confirm.
Sir, when will we
correlation.
receive the qualifier exam hall tickets, sir?
But hall ticket you would have got, right? If somebody hasn't got, I guess.
Nobody got it, sir. Nobody got
Like if you haven't got it, then you'll be getting it maybe in the coming 1-2 days. Okay.
Sir, I have
Sir,
one doubt.
graded assignment 4, sir. Hello, sir.
Yeah, graded assignment 4, which question?
Sir, that contingency table, sir. So when they're
Okay.
asking about the proportions of the total students are divided, so we know to calculate, sir, but the confusion arises when they're saying enter the answer correct to the 2 decimal accuracy. But when we are, I was been seeing the videos of the ma'am, so where ma'am calculated in percentage, and also the proportion also was written in the percentage. So it was a confusion that how to write in decimal level or in the percentage. So I wrote it in decimal level. So now I got my graded assignment. Everything is wrong because in the video I was checking to how to write if it's a proportion, how to calculate, and how to write
One second. What proportion of the students? So how did you write? Like you wrote it like 0.75 or 75 point something. How did
Sir,
you
I
wrote?
wrote it like 23.03. Actually, the answer is 0.22. It is varying like
Yeah.
that.
So if you have been asked the proportion, that means you just have to divide everything with 100. Okay.
Okay, sir. But so that was the confusion. Like
So that's why they have written something. So decimal up to 2 digit. That means what they want you to write everything not in the form of a percentage. So if you have been given that you have to write something in the form of a percentage, then you would have written in the form of a percentage.
Sir,
But
in the 12th question, they have asked the percentage, sir. And in that also they enter the answer correct to the 2 decimal accuracy. So that is the confusion arises. Whether for percentage we have to write actually to the percentage or to the proportion where we have to write in the point. So that is the confusion arising, sir. So that is the thing. I don't know how to clarify it. So as you are saying, if they are asked percentage, you can write in percent. But there is a 2 questions, sir. You have to write the proportion also.
I got your
Because I checked the videos of where ma'am was giving the explaining about the contingency table. So I gone through that, and then she was explaining about the proportion, and she was entering in the column in the percentage wise. So I thought, so we have to write the percentage with the decimal.
Okay, got your point. So you can just think of in the exam also, if you have been asked to write the proportion, so you have to write it whatever the percentage that you have got, divide it with 100 and then write it. If you have been asked to write the percentage up to 2 decimal, you have to write it in this form 75.45 something like that. If you have been asked to write it in the form of proportion, so the same 75% you will write in the form of 0.75.
Okay,
Got
sir.
it?
Okay.
Yeah.
Got it, sir. Thank you, sir.
Excuse me,
Because
sir.
my graded assignment got low marks, so that was I was worrying about. So I don't know how.
Okay, no problem. So graded assignments, all graded assignment won't be counted. I guess only 2 or 3 will be counted.
Excuse me, sir.
Thank you,
Sir,
sir.
excuse
I
me, sir.
had a doubt.
Yeah.
I
Sir,
just came
yes.
across a question where 2 standard deviations were given, one of population and another one of sample. And we were asked to find n in that case. I tried it multiple times but was unable to get the answer properly. Can you explain this?
Which question?
There was a question, I think in PYQ. It came like 2 times.
No. What was that question? Can you give me an idea like what it was trying to ask?
In that question, there were 2 standard deviations were given, one of population and another one of sample. And we were asked to find the value of n in that case.
Okay. So then you can calculate it, right? So what's the issue? So you just take it as, so I'll just.
We will find out the summation x minus x minus
Yeah,
h
correct.
bar square then.
Correct.
But I am not getting the correct answer. I tried it multiple times. Can I tell you the number? I mean the values
Share
of
the
the standard
screenshot.
deviation.
Maybe share the screenshot in the chat box. And
Sir,
about
sir,
quiz paper,
week 3
I'll
graded
just
assignment.
clarify
I
one
can
more
tell you
thing.
now.
I'll just
Like the
clarify
SD of
one.
population was 11 and that of sample was 16 in that way.
No, I didn't got any question.
Sir.
Excuse me, sir. I have sent
Sir,
a question.
week 3 graded
Question
assignment.
number 10.
Okay.
Sir, week 3 graded assignment.
Week 3 graded assignment. Which question?
Question
Sir, I have
number
sent
2.
a question in the chat.
Sir, question number 2.
Half an hour ago.
Okay, question number 2.
Yes.
I want to clarify. So somebody is asking about the quiz one. It won't be, so it will be in the form of, so you'll be getting the question in the form of NAT, subjective, MSQ, MCQ. Okay, so multiple select or the one of the 4 is correct. So there won't
Sir,
be
all,
pen and
sir,
paper
all
exam.
will be in MCQ only. Sir, all will be in MCQ only.
No, all those questions won't be MCQ. Some questions will be NAT also. So you'll have to solve and write the value. Okay. Numerical
Sir, we have to solve it in steps.
You don't have to write pen and paper. Pen and paper exam is not there. You just have to mark it as like you just have to put the values that you have corrected. So MCQ, MSQ, multiple select also can be correct. Multiple choice is also correct. And then NAT can also come. Okay.
Sir, NAT means we have to solve it stepwise or what?
Not solve it. Just have to get the answer. however you're solving, we are not worrying about that. You just have to solve and put the answer there.
Okay, got it. Okay.
Okay.
Sir, week
Like
3
your graded
graded
assignment.
assignment. Sir, week
Correct,
3
correct.
graded assignment
Maths
question
class
number
has
2.
started.
So please explain week 3 graded assignment question number 2.
Yeah, week
Sir,
3.
do we get any rough
Sir, week
paper
3 graded
for
assignment question number 2.
rough works?
Yeah, you will be getting the paper for the rough work.
Sir,
what
sir,
will
question number 2. Sir, question number 2.
Excuse me, sir.
So question number 2, what is the question? Is this mean you have to calculate or what?
No, sir. Let me. Sir, the question was given the mean and the sample standard deviation of data set consisting of 6 observation data.
Okay, so the mean, okay, let me check where is that question.
The mean and the sample standard deviation of the data set consisting of 6 observations is 12 and 8 respectively. Later it is noted that one observation 19 is wrongly noted as 14. What is the mean of the original data set?
Hey, 1 second, somebody is Alexa. I don't know who is asking continuously the same spam. So sigma, sir, sigma x refers to the sample or the population standard. So wherever the sigma, so they'll mention it. So if you're asking about the formula in the correlation coefficient, then you have to take this population standard deviation. But in the question, they'll ask you, they'll specifically mention you, okay, to calculate the population standard deviation or the sample standard deviation. Okay, so do not worry about that. Okay. So many a times sigma x can be represented as the standard deviation or the sample or the population also. But in the exam, they'll ask you to calculate the sample or the population. Okay, so don't worry about that.
So week
So now
3
please
graded assignment question number 8.
So please
So
explain
week
question
3
number
question.
2
See
first.
the question. See the problem is whatever you have the question, I don't have the same question. Okay. So if
sir,
question number 8, if I'm reading it out, this is something like in the deck there are card numbered from 1 to 9, something like that, or there's a different question.
Yes, sir.
Okay. So I'll just solve that question.
So question
Excuse me,
number
sir.
2, sir.
Sir, I have sent the question in the chat. Please, can you check this? Question number 10 from week 1.
So what is the impact of adding or multiplying a constant with the correlation coefficient?
No, correlation coefficient, you'll have to check how it is getting impacted. See, the formula is what? So basically your formula in the upper side, what? So first of all, it is what? So in the numerator, you have what? Numerator, basically you have x minus x bar, and then you have y minus y bar. So you'll have to check. So you'll have to write it down and then check how it is getting impacted. Okay, there's no hard and fast rule for that. Maybe I'll have to check that.
Sir,
Okay.
question that was I am
Thank you.
asking, I had written it in the chat. Please check it out.
Sir, I have sent the question number 10 from week 1. Can you please check it up?
No, first I'll just deal with the graded assignment. Somebody's asked me question number 8. I have somebody else.
It
So
is from
question
graded
number
assignment
2.
only.
No, I'll go there, but first I'll just one by one I'll solve, right? I can't
So the
go.
question I am asking
So
written in
somebody
the
has asked me about
chat.
can you like I'll have to check. So first 8, which question? 8th question somebody is asking, graded assignment 3. Question number 8 somebody is asking.
Question number 8, yes, sir.
So what has been given here in a deck, there are card numbered from, what is that question? Number from 1
to 34.
1 to 34. Okay.
Such that the number of cards of a particular number in the deck is same as the number on the card. Which of the following statements is or are true about
No,
the
there's
mean?
nothing. So okay. So one card is occurring once. Number.
Sir, I
So
have a
this is the
doubt.
card.
Mode is defined for the data.
So card number has been given to you, and this is the frequency has been given to you. Okay. So
yes,
card number 1 is occurring once. Card number 2 is occurring twice, and similarly card number till 34 it is occurring 34 times. Okay. Now you can calculate it, right?
Okay.
Are you getting me? Yeah. So if you have to calculate
I
the
got
mode,
the question.
will...
Okay. I got the question now.
Yeah.
Can you
So
please
this is
explain
what
second question? I am not having any idea how to solve this question, please, sir. Question number 2.
So question number 2, is it asking about what is the mean of the original data? This is what it's asking?
Yes, sir. Original data set. Yes, sir.
Okay. So what are the data point has been given? The number, what are the number has been given to you?
So let
So
me
some
speak.
number has been given to you. Some A, B, C, D has been given.
Yes,
What
it
is the
is,
data point that is given?
So it is saying the data sets consisting of 6 observation is 12 and 8 respectively.
No, so the question that I have is different.
No, sir, let me speak. Sir, it is the question was that the mean and sample standard deviation of the data set consisting of 6 observations, which is 12 and 8 respectively. Later, it is noted that one observation 19 is wrongly noted as 14. Then what is the mean of the original data set? Sir, I had written in the chat. Please check it out, sir.
Okay. So you have so many people are asked has kept so many questions.
Sir, I am again. Sir, I am again.
No,
sending.
So what is that question? Okay, so the mean and the standard deviation of the data set consisting of 6 observation is given as.
Yes, sir.
Later it is noted that one observation 19 is wrongly noted as 14. What is the mean of the original data? So what's the doubt here? So you don't have to see the sample. So write the formula, right?
Sir, I'm not able to understand that what is saying that 14 and that all. Please explain it.
No, it is saying this mean. So mean, you already know the summation of all the data points. So the 6 data point has been given, right? So xi plus x1 plus x2, x3, x4, x5. X6 upon 6 is equals to whatever the 12 has been given to you, correct?
Yes, sir.
What do you mean by sample standard deviation? How do you calculate the sample standard deviation?
Sample standard deviation, we just put the value. But
So you
I'm
have
not able to get that. What is the saying that one
No,
observation is noted 19 and it wrongly as 14?
No,
That
it is just saying that, see, earlier they took 6 observations, 6 value they took it, right? Later it is coming to know that, so one of the observation you have taken it incorrectly. So whatever you have calculated, so one of the 6 was incorrect. And what was that incorrect? 19 was incorrect and was wrongly noted as 14. Okay, later it was noted that one observation 19. So earlier, so you have done everything with respect to 14, but that is so, but the original data point is what? 19. Okay.
Okay.
So now what is the change? So you just write all those formulas, okay, and you have to just remove one of them and then exclude one of them and include the other one, okay, and then you'll get it. So it's not that difficult, okay.
Yes, yes. Thank you. Okay.
And this is also written as a sample, so you'll have to take n-1. So all those things you have to take.
Okay, sir. Thank you. Thank you.
So somebody is asking about what is that? It's asking what is that? The graded assignments. Question number
Sir,
10.
question number 1.
No,
Sir, question number 10 from week 1.
Yeah, question number 10 from week 1. Just
So next out, please take mine. I've been here for a long while.
So these are some theoretical questions that you should be knowing, I guess.
I have a problem in the option B that just a second. Yes, yes, sir. The option B, it is saying number of assignments submitted by a student has an interval scale of measurement, but it can be also absolute zero, and it can also be ratio scale.
Yeah, it can be, but here, so it can be, but it is asking for incorrect options, right? What it is asking.
Okay, sir.
Yeah, it's asking for incorrect, right? So you'll have to choose incorrect options.
Yes, sir. And sir, I'm having also problem in week 2, practice assignment question 1 and 3.
Practice assignments. So
Practice assignment 1, question number 3.
So 3 is a pie chart, right? This is what you're asking?
Yes, sir.
Okay, what's the doubt? So this is simple, right? What's the doubt here?
Sir, the problem is like the budget is
So it's just as the expenditure for the month of October has been given to you, and if
yes,
50,000 was spent on shipping, okay, so 5% is okay. So you just have to divide what has been given. So 50,000 was spent on shipping, and then what are the total expenditure for the October? So what's the issue? So 5% is 50,000, then you have to calculate the 100%.
okay, sir.
Yeah.
And sir, can you please tell me just in brief about the first question of practice assignment 2 of week 2 only?
So you have been
Just
bar chart, right? You have been given a bar chart. Then you have been asked what percent of student has chosen biology or politics. So you'll have to just add the biology and politics student. That's it.
no, sir. From practice assignment 2, where it is given about the train, Rajdhani trains.
Okay, 2 you're asking. Okay, let me
Yes.
check it. Question number, which one?
Sir, the first one, it is given about the information about 1, 2, and 3.
So question, what is the percentage of birth filled in a train on the given day? This is what you're asking?
Yes, I have a problem that 9 third AC coaches are there and 64 berths are respectively in the third AC coach. Sir, then how can be 275 third AC berth can be filled if there are only 64?
No, see, this question is just given that there is a train that connects national capital of India and the state capital of India, or to the biggest city, the Rajdhani Express is running from Sikandrabad Junction to Nizamuddin Junction. Has one AC first class ticket coach and 5 AC second class and 9 AC. Okay? And then each of this has a maximum capacity of 18, 48, and 64. So on the given day, 10 like the first coach berth and the half of the second were filled. Okay, then you have to ask what percent of berth was filled. Okay, then see the berth was filled. How many was filled? So whatever was filled upon the total number of capacity. Like, so what's the issue in this? This is pretty simple, right? What's the issue that they are facing?
Sir, the issue is it is
But
written
what is the
each.
total number of berths? How did you calculate the total number of berths? Basically, you have 18 berths, 18 into 1, and then what is that? 48 into whatever the number it has been given. Yeah,
So
yeah.
there are 64 berths in the third AC as it is written in the question.
Okay.
Sir, and in the last line they are saying 275 third AC berths are filled.
No, but okay. So let me check it once again. What has been written here? So the information that has been given here is as 1 AC first class, 5 and 9. There is 64 in one third class, but there are 9 AC third class, right? So 64 into 9 is the capacity.
Okay, sir. Thank you, sir. Sir, in the question number 8, it is given about the languages which are spoken in the India.
Okay.
And percent of total population is given in India, that how much people are speaking that language.
Okay.
So if we arrange this in the ascending or descending order, can't we just take that what is happening at which language is there on the 50th percent? If we just say that Hindi is the if we are putting in the descending order and Hindi is the most speak language, so it will be on the first and it will be 43%. After that it is Bengali.
What is your question? What is your question?
So if it is 43 plus 8, it will be 51. And can't we say the median is Bengali? Because in the question number 10, the median is asked.
No, median is not defined for this type of a data set. Median can't be defined for this type of a data set.
Sir, if the population, the percentage of the total population is given, then also.
No, it's not defined for this type of data. This data set is totally like you can't define median mode for each of the any type of a like the variable that you are getting. For this type of data set, median you can't define median. Okay.
Okay, sir. So if we have a tabular data,
then I
in
have
the
to. Yeah, I'll have to take some other doubt also. For some other people.
Thank you, sir.
Yeah.
So may
Thanks.
I ask?
Yeah.
So my doubt is from the mock test, the mock 2.
Mock will be discussed. We have one more session, so all the mock paper will be discussed. Okay, don't worry about that.
So I waited for so long. Can you please solve that one? That's just a very small question. It is. Yesterday I also asked the same question, but then that teacher said that ask tomorrow. That is why I was waiting. Please.
Okay, which question is that?
Question number 13. It's based on the stem and leaf plot.
Mock test, which one? Mock test 1 or 2?
2.
So mock 2 question number which one?
13.
So question number 13. 13 is what? 13 is?
The
stem and leaf.
Stem and leaf, yes.
Okay.
So how are we supposed to solve these sort of questions is what my question is.
Based on the data published in the Statistical Handbook 2020 by the Department of Economics and Statistics, Government of Tamil Nadu, the average rainfall recorded in Tamil Nadu during this is given below. Okay. What scale should we use in stem and leaf program such that there are exactly 9 stems plotting the stems in the plot? Okay, so you'll have to choose such a scale. So it's like a hit and trial. So first choose first, okay, and then check that whether if you're just taking this as a scale, are you able to put 9 stem or not? Are you getting my point? So similarly, check the second data point, second scale, okay, and then check whether you are able to put 9 stem or not. 9 stem, like you are able to understand that, right? 9 stem is a left, okay. Similarly, you can check it for the third option and fourth option. Okay, it is a hit and trial method. You don't have to think of how are you going to calculate. So this just the first you just take. So you just wherever you have 598.1, so you just take it as a 0 as a stem and then 590. So first two itself is incorrect, totally incorrect. Now you have to just check for the second, third, and fourth. Okay, even I guess fourth is also totally incorrect. So you just have to check for the second. You got an idea, right?
Yes, but the second and third one are left. So in dono mein, how are we supposed to figure out?
Yeah, so you have to write it. So for this, just consider second as your standard method. Okay, and for each of the data points that has been given to you, rainfall. Okay, just try to put it in this way. If you have a data as 598.1, you just take as 0.5 as the first case and 98.981 as the other case. Okay, similarly, just convert all your data point in this case and then try to write it. If you are getting 9 of the stems, then you can just put it as second as the answer. Okay.
Oh, all right.
You'll not be getting this type of problem. I'm telling you, if you're getting this type of problem, will be defined already, and then you'll be just have to plot the stem and leaf. Okay.
Okay. No, I got it. Understood.
Yeah.
Sir.
Thank you.
Excuse me, sir.
Sir, the exam time
Yeah.
was morning or afternoon?
Yeah, it can be morning or afternoon, anything. So there is like so it can be. So it depends on the like what you are getting. Okay, it can be morning or afternoon.
Yes, sir.
Excuse me, sir.
Yeah. Anything else? Yeah.
Sir, I have a doubt. Sir, can serial numbers be called as categorical variable?
Okay, where is that questions?
Yes, sir. It was in practice assignment 1.2. Before question number 6. There's a table. You can see that.
Okay, so question number?
Before question number 6, a table has been given.
Week 1 or week 2?
Week 1.
Week 1. Question number? Practice assignment 1.1.
1.2.
1.2. Question number?
6. Above question number 6, there is a table given. I have a doubt in that table.
Okay. So we have been given something like bike enthusiastic, something like that, right? Naresh is a bike enthusiastic and then wants to know about the specification of all the bikes. Is it the question or the different one?
So the question is, Karthik wants to start a shoe production company for all the Indian market. That type of question.
Okay, but
should I add the image in the chat?
Yeah, maybe you can try it out. Yeah, you can just send it out.
Yes, sir. Please wait.
Yeah, so, and one more thing I want to clarify is this. Try to solve the previous term paper, okay? That will be your best, like, that will give you a best idea about which type of problem is going to be asked in the exam, okay? Mock test is fine. If you have solved it, that is totally fine, but try to solve the previous term paper. Get it from somewhere, like maybe from friends, colleague, or seniors and all. Try to solve those papers, okay?
Sir, I have just shared in the chat. Could you please check?
Yeah. Okay, so we have been given something: name, source, material, purpose, price range, and then suggestion. All those stuffs have been given to you. What's your doubt? Can you proceed the question also? Which question?
So the question was, how many variables from the collected survey data are categorical? I want to ask that, is serial number categorical?
So if you'll just see that here, so material can be a categorical data, right? Even the purpose is a categorical data. Price is also categorical data, right?
Yes, sir. So name is also categorical data.
Okay, you can think of in that way. That name also as a categorical, like. Okay.
Also, so I want to ask if serial number can also be called categorical data.
No, how will you consider serial number as a categorical data?
So why not?
No, how will you calculate? Like, how will you take serial number as a categorical data?
So we can't perform
Can't do. Serial number is like
operations on
irrespective.
them.
Like, no, like what type of things you want to calculate? Serial number, you can't do anything on that. Right? Serial number is irrespective of anything. It doesn't have any impact. So serial number is not categorical. So is there any significance? So there is no significance of the serial number, right?
Yes.
Yeah, so and so do not get confused with, so serial number and all, you don't have to take it like categorical data.
Okay.
Yeah. Okay, so what I'll just give you an idea about the quiz paper. So the quiz paper mostly will be, there won't be any difficult questions, that I can tell you. Okay, so most the paper that I've seen, all the questions are mostly very basic questions have been given to you. Okay, so the questions can be related to relative frequency, or maybe to calculate the mode, the population standard deviation, and the data set will be pretty simple, because we are not checking you, because you don't have the hand calculator, and then we are not asking you to calculate everything. We are just checking the concept that you know. So the basic things you should be knowing. Okay, the basic concepts about from week 1 to 4 you should be knowing. Like I told you, the impact of adding some constant or multiplying some constant, or the effect of outlier on the mean and median. Okay, so the nominal scale, also all those 4 data points. That so all those 4 type of scaling measurement, or you can say, or you can be given some sort of a pie chart or a bar chart, and then you can be asked to calculate some sort of a percentage. Okay, so this type of problem can be asked in your exam. There won't be a difficult type of a questions like to calculate a correlation coefficient, and then you will be given a very n number of data points, like 10, 15 data points. That those type of problems will not be asked. You can see the previous term papers also. You can be asked regarding the correlation coefficient, but you'll be given some sort of a plot, and then you'll have to check whether it's a positively related, negatively related, how strongly it is related. If the value of R is very high, 0.99, is it strongly related? If the value is minus 0.99, is it negatively related? How strongly? So those type of problem will be asked. Okay, there won't be any confusing question like R equals to 0.5. Then the option can't be like weak or moderate or strong. So this type of problems will not be asked. Okay, this is what I'm trying to say. So do not get, so just go through each and every basic concepts from week 1 to 4. Will be able to solve all those problems in the exam. Okay,
Sir, in exam there is a calculator used.
Calculator will be there. Yeah, PC calculator. So you can't take your calculator, hand calculator, but there will be a calculator like the TCS calculator will be there on your laptop, like in the monitor itself. Okay.
Yes, sir.
Okay. Okay, then all the best, everyone, and yeah, bye.
Bye, sir.
Yeah,
Sir, how many hours will it is?
So each paper will be of 1 hour. So we'll be having altogether 4-5 hours of paper. Like if you are having 4 papers, we'll be having 4. If you are taking 2 papers, will be your timing will be of 2 hours.
Yes, sir.
Okay?
Thank you. Thank you.
Yeah. Thank you. Thanks everyone for joining the session. Okay. Bye.
Bye, sir.